top and dense water at the bottom. So what do you observe here? That in the sea, you have in certain situations and in certain cases, you have fresh water on top and denser saline water at the bottom. So can we say that there is an arrangement in the form of layers? And that is what we refer to as stratification. Stratification basically is again derived from the term strata, which means layers. So stratification of oceanic water here refers to arrangement of oceanic water in the various different layers, right? So this is what is referred to as, I will give you the definition as well later on, so don't worry about it. So this is stratification of oceanic water. Okay? So wherever you have large number of rivers coming in, can we say that in those areas stratification can be observed? We can say that, right? Now, as compared to Arabian Sea and Bay of Bengal, where will you observe stratification to be more common? Arabian Sea or Bay of Bengal? Good. Always Bay of Bengal. That is where you have larger amount of fresh water which comes in. Now let us develop the concept. Now, here, let's consider another area where you have saline water through and through. Okay. Now, both of these areas receive solar insolation. That is, significant heating by the sun is received. Now, I will have some assumptions. Let me know if you are comfortable or not. So here, when we talk about this, so here, we will have the solar insolation because the water is obviously transparent. So almost transparent, translucent of sorts. So you will have the heat being transmitted all around. Whereas in this case, heat will significantly be concentrated in the top portion because there is a kind of a layering which has been done. So heat will be concentrated in the top portion. Some amount of that heat might percolate in the lower portions, but majorly heat will be concentrated in the some area. So just apply the same logic that we applied in the case of talking of land and water. So out of A and B, where do you think that surface water will get much heat, much hotter, and that too quickly? Where do you think surface water will get hotter and quickly? Always in the case of A, because in B that heat will be distributed, spread across, whereas in A that heat will be concentrated, right? So in this case, heating of the surface water is more frequent and more intense. Now, when the sea surface water in the tropics, when they get heated much more intensively, which atmospheric phenomena results out of that? When the surface of the tropical seawater gets heated more intensively, which atmospheric phenomena develops? Very good. Tropical cyclone. So tropical cyclones are created when that temperature rises beyond 27 degrees Celsius immediately. There is a development of tropical cyclone. So here, that is the reason why when we talk about the occurrence of cyclones, you have more occurrence of cyclones in the region of Bay of Bengal as compared to the region of Arabian Sea. Is that understood? Is that understood now? If river water floats upon the ocean, then how it erodes the soil? It is the sediments which get deposited and which have a flow. Okay? Is that understood? Good. Right? So basically, that is the reason why you will have greater occurrence of tropical cyclones in the region of Bay of Bengal, in the region of Gulf of Mexico, because there also you have large rivers such as Mississippi, Missouri, etc. You have rivers such as Rio Grande, etc., that end up draining into Gulf of Mexico. In the region of South China Sea also you have large number of rivers draining into that area. So this is the reason why these areas, they are much more frequented by tropical cyclones. That is a concept that you don't find in the books, and that is a concept which is important to understand the occurrence of cyclones. So now you will be able to answer the question why you have more tropical cyclones in the region of Bay of Bengal as compared to Arabian Sea. So now if you are writing the answer that why more tropical cyclones in the region of Bay of Bengal, you can talk about the fact that how Bay of Bengal is narrower as compared to Arabian Sea. So the temperature rises very frequently. You can talk about how the normal Walker cycle, the case of La Nina, the case of normal IOD, the case of negative IOD, all of them can create low pressure areas around Bay of Bengal, induce tropical cyclones. Then stratification of oceanic water also induces tropical cyclone. So that covers your answer from all the perspectives. A question of climatology need not have the answer included only of climatology. A question of oceanography need not, the answer need not be restricted only to oceanography. The better you are able to interrelate the various concepts, that is what will create a difference. Otherwise, everybody studies the same books, everybody extracts the same material. Okay, so here that is what is referred to as the stratification. I'll get you the definition of that as well. Now, here when we talk about it, so we talk about the vertical distribution of salinity. So salinity at the bottom is largely consistent, around 35 parts per thousand. Salinity at the surface, it keeps on varying consistently. Why? Because when we talk about salinity at the surface, it will be impacted by evaporation, precipitation, ocean currents, etc. But all these, as we have seen earlier, they are surface phenomena: melting, freezing of ice and glacier, influx of river water, etc. They won't be impacting the depth of the ocean. These are all major surface phenomena. So salinity at the surface will vary from one latitude to another, but salinity at the bottom will largely be consistent. Now, just like in the case of temperature variation with depth, we also observe that there is a variation on the surface, and in order to attain the consistency at bottom, there is a zone of transition where salinity suddenly changes. That is what we refer to as halocline. Okay, just like earlier we had thermocline, here we have halocline. So salinity changes with depth, but not same on all locations. Salinity at the bottom is largely consistent. So halocline, it is very similar to thermocline, but it measures the change in the salinity zone, distinct zone of salinity change that is experienced. So here, basically, the salinity at the surface is consistent. At the surface is consistent. I will take the doubts for the final 10 minutes. Don't worry, guys. I'll take all your doubts. Most as much as I can. As the surface is consistent, or not surface is consistent at the bottom. Salinity at surface varies. At surface varies. Okay? That is where you will have that zone of transition where the salinity tries to attain that consistency at the bottom, which is around 35 parts per thousand. That is the zone of transition is referred to as the halocline. This is what is the zone of transition. Okay, so here you will observe, for example, here you will observe that how at the region of the equator, the salinity is roughly around 35. The salinity is highest where? At the tropics, because the evaporation is high, precipitation is low. So here you will observe that the salinity suddenly reduces as you go to the bottom. In the higher latitude as well, the salinity varies to come to the consistent level at the bottom. So that is where you have the zone of transition, zone of transition, and this zone of transition is halocline. Okay. Now, higher salinity water is much more denser and stays below the water having lower salinity, because salinity is also something which impacts density. So higher the density, it goes to the greater depths. So this leads to ocean stratification, that is arrangement of oceanic water in terms of layers. So that is what is referred to as the ocean stratification. Now, higher salinity in water bodies, when we talk about the most saline waters in the world, you have Lake Van in Turkey, then you have Dead Sea, then you have Great Salt Lake. Now, Lake Van, you will observe that it has got salinity levels of almost 330 parts per thousand. That is, that means in 1 kg of seawater, you have 330 grams of salt. In Dead Sea, in 1 kg, you have 238 grams. In Great Salt Lake, in 1 kg, you have 220 grams. So these are very saline. Most of them you will find, almost all of them you will find, they are present in the subtropical high pressure region, meaning there will be very little amount of rainfall, significant amount of evaporation. So that is where in these subtropical high pressure zones, you have significant amount of salinity, high amount of salinity. Okay. Now, then we come to the aspect of density of seawater.
এদিকে না ওদিকে যাও
Density of seawater.
No. পড়বি কিন্তু
Okay. The density of seawater. So when we talk about the density, so density is what? How closely the particles, the materials, they are arranged. That is what is density, isn't it? So when we talk about the density of seawater, so that will be impacted by salinity as well. That will be impacted by temperature as well. Both of them will impact the salinity, isn't it? So here, or both of them will impact the density. So here, when we talk about the density of seawater, controlled by temperature, controlled by salinity. So, if a water is, let's say, very warm or very hot, in that case, what do you think will happen? If the water is very warm or hot, in that case, what do you think will be the impact on density? Will the density increase or will the density reduce when the water is very warm or hot? So I guess many of us are unable to understand the meaning of density in itself. So, okay, fair enough. If I talk about this seawater, I'll talk about two samples. Then then we will understand what is density. Here, if the particles are arranged like this, okay, and here the particles are like this. This is A, this is B. Let me launch a poll so that I have a get better visibility for you guys as well. So here, which will have higher density out of A and B, which has got higher density? Obviously. So Harmeet, please take a look into what is density first. Okay. Okay. So we have a very
পড়বি কিন্তু
small
বাবা
minority for whom density is not clear. So density represents that how closely are the particles packed. That is density. So here density in this case will be higher. A's density will always
আমার
end
লুলু
up
পুতু
being
পুতু
higher.
আমার পুদু পুতু পুতু
So density is contributed by temperature. Density is contributed by salinity as well. So when we talk about now, these are very basic portions of science, guys. I assume you would have studied in your class 7th, 8th standard. Okay, so if not, so kindly go pick up the book for the class 6 to 10th NCRT, the science books that you have, the very basic science book for school. So do take a look at that. You will understand what is
ওদিকে যাও তো
mass,
বাবা ওদিকে যাও
what
ওদিকে
is
যাও
volume, what is density. You will get a clear concept of that. Okay. So in this case, when we talk about density, so
দাঁড়া দাঁড়া
because water is warm, particles will escape each other. So the density will reduce. If the water is very cold, the particles will come closer, just like in the case of air. So if the water is very cold, particles will come closer to each other. They will pack themselves closer to each other. So then the density will be higher, isn't it? So here, cold water is denser
এই
than
ইস্যু
warm
করবি না
water.
ওদিকে এনে
Okay? And water with high salinity is denser than water with low salinity. Now, let us consider another case here. When we talk about, let's suppose the tropics. Now, in the tropical region, what can we say about the temperature? Temperature is high or temperature is low in that area? What do you think? Temperature is high? Significantly high? So as per this, the density should be lower. As per this, density should be low. Isn't it? What about salinity? Salinity level and the tropics is high or low? It is the highest. The oceanic water salinity is highest in the region of the tropics. We have just now seen it repeatedly. So this is where it is the highest. So as per this, the density should be high. Should be high. Okay. So as per the factor of temperature, density should be low. As per the factor of salinity, density should be high. What will be the outcome? So whenever
এই
you
ওখানে
have
ইস্যু করে
both the
ঢুকতেছিস
factors
এদিকে
at play,
তাড়াতাড়ি না
it
তো
is
কাঞ্চি
the
আদর
temperature
কামড়
which
হবে
is
কিন্তু
the
আজকে আদর
dominant
কামড়
factor. Because when you have a saline water which gets heated, there
তো দিয়ে দিবা না
even the
দাঁড়াও না
saline water
তো
will
এখন দিলে
tend to
এখনই পেয়ে যাবা
expand. Heating leads to
যখন টাইম স্পেন্ড করো
expansion.
তখন বলা যায় না
So if the saline water gets heated, so even that saline water will expand. So whenever both the factors are at play, temperature will be the determining condition. Okay, so whenever both factors are at play, temperature is the determining condition.
हाथ खुला है बाप रे क्या
So even though the salinity is high in the tropics because of greater amount of evaporation, still even that saline water will expand. And whenever it expands, density will reduce. Now, this induces a large scale circulation in the oceans due to the difference in temperature and density. That has got the potential to induce very large scale circulation in the oceans. And I say large scale circulation, I mean from the region of equator to the region of the poles.
हमारे इधर मिशन
So,
आई
how does that happen? Let us analyze that. Let us
कुछ
understand.
सेकंड
And what is it referred to? So, here we study that under the heading that is thermohaline circulation. These circulations are so very important for the distribution of heat from one region of the ocean to another, for the distribution of nutrients and minerals from one region to another. Many of the marine species, they are dependent on these circulations for the availability of nutrients for them. Okay, let us take a look at this. So before that, let me give you an idea about the average sea level. Let's suppose this is your average sea level. I understand this won't be very significantly visible as of now, but please bear with me for a few moments. Now, in the region of the, let's suppose we consider this as the tropics or the equator, and let's consider this to be the polar region. Now, around the tropics, around the equator, the heating is very significant. Now, whenever heating happens, any state of matter will always expand due to heating. So, water also expands around the region of equator, around the region of tropics, generally around the equatorial area itself. You will observe that due to very high amount of solar insolation, there is a great amount of heating, due to which water expands in that area by an amount of close to around 8 to 10 centimeter. So 8 to 10 centimeter. It is not very significant in the large scale of the process and the larger scheme of things. But even that 8 to 10 centimeter expansion, let's suppose water expands here. It expands by around 8 to 10 centimeter. Now, in the region of the poles, the temperature is very low. Temperature is very cold. So when the temperature is cold, can we say the things will compress a bit? The state of matter will compress a bit. So here you have water which tends to compress a bit due to significant amount of cooling.
दारा
So around the tropics, around the region of equator, you will find that the water has expanded due to significant heating. Whereas around the region of the poles, it has shrunk, it has compressed ever so slightly due to significant amount of cooling, isn't it? So what has this done? This has provided a height gradient. Water always flows from a greater height to a lesser height. Even if that height gradient is little, water will induce a flow. So water here tends to flow towards the region of the greater height, towards the region of a lesser height. It tends to flow because of the height gradient. So flow is induced due to height gradient. Due to height gradient. At equator, I hope you'll be
देखिए
able
भाई
to write it down that there
सुने
is
हो
expansion due to heating. Now, here we will come to the polar region in a brief moment. But from the region of equator, from the
चांग
region
मेरा
of the
तक है
tropics, the water has started flowing away, the surface water, because of the height gradient. So, what do you think will happen there? Will there be the case that the water level will now come down? Or will there be the case that the water from the subsurface will rise up, will replace, will also get heated, will also get expanded? So obviously, water level won't come down. So here you will have the water from the lower region in a form of upwelling, which will rise up. But rather than lowering the
বাট
temperature of the
ওটা নেওয়ার
surface
জন্য
water,
চাচালা হয়
this water which has risen up, that will also get heated up. That will also expand. That will also induce a flow. Now, as it is flowing to the polar area, it is getting colder and colder. Then, after a point of time, it will come to a region where it starts freezing up, isn't it? It will come to a point where it starts freezing up. So, let's suppose here you have the freezing.
আজকে হচ্ছে
What portion are you asking
17
about house, sir? Which
18
portion? Let's suppose
17
it
18
starts freezing,
23
right? Into ice caps. So, when the freezing happens in the region of the poles because of very low temperature, it is not that the entirety of the water column will get frozen. Some sections will get converted into some ice chunks, icebergs, etc., which keep on floating around. So, whenever that freezing happens, what happens to the salinity level? Salinity goes higher or lower at the time of freezing. What do you think? Salinity increases. Now here the temperature is also low. So if the temperature is low, salinity is high, what do you think will happen to the density? Density will increase or
পড়বি
density will reduce? What do you think? Density will always increase. And denser water is the heavier one, and that is where it will sink. So as the freezing happens, salinity increases here. Salinity increases. Temperature is also low, so the density increases as a consequence. Density increases. Density is calculated by the simple formula of mass by volume. So here, basically, as it gets denser, it will start to sink. Water sinks. And then, at the lower level of the water, can we say that here you have a vacancy because the water has risen up? Isn't it? And can we say that here you have a kind of a surplus because more water is sinking? So that will induce a motion,
ওই নাম তো
and a
নাম নাম
circulation
নাম
is induced.
আনবো
And that circulation which is
কালো গিটা
induced
কোলে বসে
is
খাওয়া আগে
purely
খেয়ে নে
driven by
চুপচাপ
the density. At equatorial region or at the lower latitude, the density is lower because of heating. At the higher latitude, the density is higher because of cooling as well as salinity. So there you have a circulation induced, where on the surface, water moves from lower latitude to the higher latitudes. In the subsurface, water will move from higher to lower latitude. This circulation which is induced, that is thermohaline circulation, because it is induced by the difference in temperature and salinity, which in a way induces a difference in terms of density as well. Okay, so here, that is why you will observe this. So denser water tends to sink while relatively lighter water tends to rise up, isn't it? So here you will observe that, yes, Subramanya, that will happen. So from the lower latitude,
সোজা
water
হয়ে
will
বসতো।
move to the higher latitude on the surface. Many of those portions will get frozen. So as the ice floats, the remaining water will be very cold and will have very high salinity, so very high density. So that dense water will then sink. It will move as cold
ওদিকে
water towards the low latitudes. So on the surface, low latitude. This is higher latitude. This is what is referred to as the thermohaline circulation. And that thermohaline circulation is very, very essential, very, very important in order to have a circulation of nutrients and in order to ensure distribution of temperature. Because when you take an average, an annual average, planet Earth always receives surplus amount of heat around the region of equator, because that is where the solar rays, the solar insolation is very direct, and the region of the poles, they are in a kind of a heat deficit, whereas the region of equator, they are consistently in a stage of heat surplus. So that is where you need the balancing of heat as well. Otherwise, the same region would continue to receive more and more heat. Every year would be much more warmer. So you need that balancing of heat as well. Okay, so that is thermohaline circulation. Now, then we come to the movement which is observed in the oceanic water, that is tides and waves. So here, first of all, we will take a look at what do we mean by waves. Then we will come to the portion of tides. So waves are something that you all would have experienced. All of you would have seen that, visualized that at least. So what are these waves? So these are basically the movement which you observe in water, where the water in itself doesn't have a or a
বাবা
forward or a backward motion. The water keeps on oscillating in the same position. It goes
পড়বি
high,
এখন
it
উল্টে।
goes low, it goes high, it goes low. So that is what creates a wave action. That is induced by what? That is induced by the movement of the wind. So here they are defined as the smooth movement undulations, smooth movement of water in upward and downward directions of surface water, characterized by well developed crest and troughs. So here, when you have what is meant by crest and trough? So let's suppose you consider this. So you have this as the crest, this as the trough. Okay, so that is the crest and trough. So why does that happen? So imagine if you have, let's suppose this as the water, or rather than this, let's assume you have a plane surface here of water. Now, generally over the sea surface, you have some or the other kind of wind movement which is observed. Some or the other kind of wind movement is observed here, isn't it? So the wind will try to pick up some amount of water. Many of the times it won't be able to carry it enough. So let's suppose this water is picked up, but after some time, it is not being able to be
খেলাম।
carried. It gets dropped here. Meanwhile, the other portion gets picked up, then gets dropped. Other portion gets picked up, then gets dropped. So
পয়সা নেই,
like
কালকে 10টার
that,
সময় বন্ধ।
you have a continuous creation
কালকে
where
সকাল
if you
10টা।
observe the movement of the water particles, the movement of the water particles is basically to and
দিবানি
fro,
তোরা
like an
এখন ভোরে কি
oscillation.
হবে, একটা দিন লস
So
হয়ে যাবে না?
water gets picked up, falls down, turns back to its normal place. Again, it picks up, again, it falls down. So that rise and fall in the same region, in the same area that you observe, that is what is referred to as
কল
waves.
যাচ্ছে না?
Okay, so when you have across the coastline, you have the waves
কল
which
যাচ্ছে
come
কি?
into the
হ্যাঁ
coastline,
তো যাচ্ছে, তো
that is
তো
what is
রিজার্ভ
referred to
করার
as
দরকার
a
কি?
swash. And then you will have the condition where across the
তো
coastline
ওটাই
you
তো
would have
বলবো।
observed that the water goes back again. It doesn't stay there, it goes back again.
এখন বললে
That
একটা
is
দিন
what is
লস।
referred to as backwash. So that is the swash and backwash. So swash represents forward motion of water by wave across coastline. And then backwash.
কে চটকান?
Backward wave motion across coastline. Wave motion across coast. Okay. So if a question is asked in the examination that during a wave motion, what kind, or during a occurrence of a sea wave, what kind of movement do you observe in the water particles? It will always be oscillatory. The water particle, they will always have an oscillatory motion. Always. Okay? It is across the coastline where they are not able to fall to these depths because the depth is shallow across the coastline. That is where they start piling up and the water you observe comes forward, but again, very quickly, it retreats back. That is the backwash. Okay? So that is where we'll restrict the session here today. Tomorrow we will continue further and we will finish the portion of oceanography possibly tomorrow.
কটা বাজে?
Okay? So that is the aspect.
8:30 বেজে গেছে।
And now let us take a few questions.
দাঁড়াও না।
How salinity is higher in cold water? It is not necessary that salinity will always be higher in cold water. In the case of thermohaline circulation, you have the case of higher salinity because as a
বাবা
result
সোজা
of the
বসো।
freezing action, we have seen earlier freezing means removal of water molecules because whenever you have freezing action, the ice largely consists of water molecules. So in the remaining water, you have more salt content, hence you have higher salinity. And Ekta, uh, very much lacking behind. I'm on lecture 13.
দুবার করা হয়ে গেছে পটি। কতটুকু
Thank you,
করে? অল্প
Ekta,
করে
for the
করছে?
kind words. I hope that the concepts are understood. Okay, and that is the aim. Sakshi, water with high salinity does not allow. So that is the factor of osmosis. You will study it. Are you talking about sinking? So that is because of the buoyancy, the force of buoyancy. Archimedes' principle you would have studied in science. So force of buoyancy is more when the density of water is higher. Do we require an extra class? We will require an extra class because on Monday we had cancelled the classes. So we will require an extra class to be taken on next Saturday. And Lakshmi, if we take amount of normal water and seawater together in a glass, same condition happen. Yes, generally the fresh water will tend to
তখন
flow.
বইখানা দিছে।
Good. Just revise. Just keep on revising that. Okay. And everybody, thanks for the kind words. And can we expect question from today's session? Yes, you can. And how to study to hit the questions which ask, for example, which river. So many of them are driven by current affairs themselves. Okay, you don't have to search for many areas, but yes, there will be always random questions. The last day also I told you, and in fact, I don't know how many of you were there. So basically, I told you about the delineation of the questions in prelims. I will do one thing at the final session. I'll talk to you about and remind me about it. I'll talk to you about how to focus on and which portion of prelims you have to focus upon. Because if you analyze 100 questions of prelims, not all of these questions are fact based, and results are never decided on fact based questions. Um, Garvit will have mapping questions tomorrow. Just ensure that whatever portions that we have talked about today, that is the portion that you look at into the map. Okay. And Fisher, I'm having more interest in IFS than IAS. Is it forest services or foreign services? Because if it is foreign services, then it is going to be decided on your rank. If it is okay, foreign services, then the preparation will be carry on the preparation depending upon the rank. If you get, it is a very good service to take. Okay, how freezing cause increased in salinity? How? Okay, so basically the action of freezing, the event of freezing, if I can take you back to the particular slide here, whenever you have the freezing action, so freezing action will always lead to removal of water molecules here from the sample, and more salt will be left behind. So in the existent water, the salt concentration will be higher than before. So that is where salinity will be higher. And Nandini, I'm new. This is my first lecture, so should I have to cover the previous topics? Ideally, yes, Nandini. See, after a couple of sessions, we will anyways enter into the portion of Indian geography. From later part of tomorrow or from Monday, we will be definitely entering into the portion of Indian geography. So that will be comparatively easier for you to consume. But if you have revised the previous modules, that is geomorphology and ocean and climatology, you will have a much better concept, or you can join a fresh or a new batch as well. Okay. And in some area, upper water are fully frozen, but underwater is in liquid form. That is because the surface loses temperature, and it is the surface phenomena. So the air is very cold, so the surface becomes very cold. Okay. Forest services, it is a very good service. It is a very royal service, to say the least, where Pavitra, because forest services, you have your own domain, you have your own jurisdiction, and nowadays forest services officials, they are even getting selected to the post of secretary level. Earlier, that was not the case. So you have a good career progression as well, depending upon which state or which cadre you get. But then it is a very good service. You you get under the portion of Ministry of Environment and Forest, and just ensure that if you are aiming for forest services, check your eligibility based upon the notification, and then also ensure that in prelims you are able to score 15 marks on an average higher than the cutoff. So then you are eligible for that. Okay, and yes, Trisha, it is the same. Chavan, THC, thermohaline circulation. That is the circulation that you get because of the difference in density in different areas. And that difference in density is driven by the difference in temperature and salinity conditions. That is what drives the entire circulation. Okay? Right? Front is a region. Front is a larger region, Basu. Twisha, get a rank in double digits or around 100, you will get the foreign services. Sarita, each of them have got their benefits associated. You cannot compare them. There are many diagram in climatology all looking same. How to remember? By drawing it on your own. Between Africa and America is high salinity is reason of trade winds. No, Chandrasekhar, that is basically driven by because in the region of the tropics you have lesser amount of precipitation, almost negligible precipitation, and very high evaporation. So when you have high evaporation and low precipitation, salinity will always be high. Uh, Yuvraj, what is the question that you sent? I'm unable to take a look into that. Do one thing, Yuvraj, send a mail. I will get back to you. Yes, Mayank, that is correct. How to practice diagram? Take a look at the annotations. You will get an idea. Is it good to mention mains answer with diagram? Always required to mention diagram here. Okay, and why heating is only on the top layer of the stratified water, Priyanshu? Because they are separated, so there won't be an equivalent distribution of heat. Heat will be restricted to the top layer. Sanchit, why is Munnar cold? Because of the high altitude. Okay, so that is where. Um, what if I don't get in 100 or get rank between 200 to 400? If you get a rank beyond 110, you won't get foreign services. Take a look at the number of seats. Is ITCZ move latitudinal and equatorial means horizontal and so it is a horizontal movement, Chandrasekhar. Okay. So that is where we'll restrict the session here today. Discussion for the portion of oceanography. So till yesterday, we have finished two major modules of geography, and that is geomorphology and climatology. Now, both of them hold relevance for the examination, but climatology more so. And in the portion of climatology, with the help of that, we have also managed to cover the portion of Indian climate. And that portion of Indian geography is something that we have covered in the portion of climatology itself. So today, we shall be initiating the discussion about the oceans of the world. And here, basically, we shall be utilizing the concepts that we have studied earlier in certain parts. And for example, certain concepts such as Coriolis force, certain concepts such as the tectonic movements, etc., that will help us understand the bottoms and the bottom relief portions of the ocean in a better way. Now, here also, we are going to adopt a kind of a similar approach where, first of all, we are going to understand the exact basic of the ocean. We are going to understand the various different regions at the bottom of the ocean, the bottom topography as it is referred to. Then we shall be looking at what do we understand by the physical portion or the physical aspects in terms of temperature, salinity, and other aspects of the ocean. That is something that we are going to look into and focus into. And then after that, we shall be moving ahead into the movement in oceanic water. So, our overall expanse in oceanography, what we are going to cover, that is going to include or that is going to be initiated from the ocean bottom relief, features. Then we are going to look into the physical properties of oceanic water.
Standing line.
Of oceanic water. Now, these physical properties of oceanic water will entail the portion of temperature, how the temperature varies as you move across from one region of the ocean to another region across various latitudes. What are the factors upon which the temperature is dependent upon? How is it that the temperature ends up varying as you move into the depth? So, that is again something that we will be taking a look into. Then, salinity. Okay. Then we are also going to take a look into density. Then after that, we shall switch and our focus into the movement in oceans. In oceans. And in the case of movements in oceans, we are going to look into the portion of waves very briefly, tides, ocean currents, global circulation, and then also we are going to pay attention into the portion of corals very briefly, so because corals in detail anyways that is covered in the portion of environment and ecology. So here we are going to touch upon the portion of corals very briefly. So corals, the or geographical requirements. Okay, so that is going to consist of or that is going to entail your entire portion of oceanography. And our entire discussion for oceanography, that is for the next couple of modules, is going to revolve around these particular topics. Now, this is a particular area which is
Square.
very relevant for your examination in general, in the sense that you do get periodically you face questions
এটা
in
কি?
the prelims as well, in the mains as well. Now, unlike the portion of climatology, here you get very direct questions. Here UPSC doesn't have much of a scope to instill a kind of a twist in that
এটা
particular
কি?
type of question which is asked. So here you have a very direct kind of questions being asked in the prelims and the mains examination, which means while it will be easier for you to attempt those questions if you
এটা
have
কি?
understood the basics, but at the same time it
নাকি?
also means that you cannot
এটা
afford
কি?
to commit mistake in this particular portion, because your competition will not commit mistake in this area. So that is where you have to
আমার মধ্যে
basically
দেখা করে
understand that.
এটা কি?
And this is where
গোল ওপরে
for prelims,
এটা কি?
temperature
মানে
and
এটা কি?
salinity
এটা কি বলো? এই এটা কি
is
বল?
important. Then other than that,
এটা কি বল?
ocean current, here types,
Sure.
and also ocean concern.
এটা কি? এটা কি?
Okay,
বলো?
so that is going to be relevant for your prelims. For your mains examination, also in prelims you get
এটা কি?
questions from the portion of types. That is also another
এটা কি?
portion where prelims
এটা কি বলো?
paper you will find certain questions appearing
কি
from
কি?
time to time again. And then in the mains
এটা কি?
examination, bottom
এটা
relief
কি?
features,
এটা কি বলো? এটা কি বলো? লাট্টু।
features,
এটা কি?
and also
রাইট মানে?
the portion about currents and circulations.
এটা কত? 3 এটা দেখো তো 5
These are something which are frequently asked in the mains examination as well.
এটা
So that is what we are going to cover. And here, if you cover this particular portion in detail,
এটা
and here you can restrict
1
yourself to the reading of the PPT plus the additional reading
3
materials, the annotations of
4
the PPT along with the class lecture. I think that should be more than sufficient both for the requirement of your prelims as well
6
as for the requirement of your mains examination.
7
So, having said that, let us initiate the
এটা কি?
discussion. So, first of all,
Yes মানে?
when we initiate the discussion for oceanography, here, when we talk about it, so in oceanography, so we have to understand that close to around
এটা কি?
70% of the
আরেকটা
total area of the planet is covered by oceans. So that means a significant majority is consisted of by the oceans
হ্যাঁ
themselves.
বুঝেছো।
So obviously the study of oceans becomes very, very
রাখলাম।
relevant.
এটা কি?
And as we have discussed earlier as well, for a long period of time, our understanding about oceans was that the ocean
এদিকে
bottom
দেখো।
would be simply plain and
এটা কি?
featureless and flat. Because when you take a look at the surface of the ocean, it appears very plain, isn't it? So that is where it was always a preconceived notion that ocean bottom would also be plain and featureless. But slowly and steadily, after the Second World War, when you had advanced equipments which were invented, which were developed, which could study the ocean floor, that is when our understanding about the ocean suddenly began to increase. Now, oceanic movements are something that we have known for a very long period of time. During the Middle Ages, also, that is hundreds of years back, whenever you had the
উঠে নাও বাচ্চা।
merchants, traders, sailors
ব্যথা করে কিন্তু।
who travel across the world, they would
দেখবে?
always, in their records, bring back the idea that where you have which kind of flow associated in the ocean. So, ocean currents and ocean circulation, we have been knowing for hundreds of years now. But it is that greater detail and greater level of understanding about each and every intricacies of the ocean, which has been a kind of a newer development. Even today, we have not managed to explore the ocean bottom to the fullest extent. Even today, our exploration for the ocean continues. And even today, we do send various different missions in order to explore what is present at the ocean bottom. And you have very famously the magazine
এটা কি
Economist, which has cited
স্ট্রবেরি
the
হলো তো
ocean bottom
এটা হবে
as the final frontier of mankind. Because mankind, we have managed to send multiple missions to the moon. We have managed to explore the moon. We have managed to explore the Mars. We are expanding our horizons in the solar system. But then when it comes to the
এটা
ocean
কি
bottom,
মার
it is
খাবে
still
কিন্তু
a
এখন
large secret.
এটা কি
So here, when we talk about the ocean bottom relief or the
হ্যাঁ
ocean
চেরি
relief
দাঁড়াও
features in general, now they are nowhere close to being plain. Now here you have the physical map,
আঁকলাম তো চেরি এটা
a kind of a map that you would have
একটা এই যে নেন
actually come across multiple times
হ্যাঁ চেরি এই
in
যে
your
আঁকলাম
life,
তো
from your childhood days, from your very young days when you would have opened up
এটা
the
কি
atlas in the school for the first time. You would have come across these kinds of maps. And at that point
এটা
of
কি
time, we are simply said that blue refers to oceanic
ব্যানানা
color and oceanic water, and we would simply color the maps with blue. Now here, if you observe the blue portion, you will find that the entirety of the region of the ocean, that is not indicating a uniformity in blue
দাঁড়া
color.
না আঁকছি তো
It
তুই
is
কেন করছিস
indicating a difference in terms of the hues and the patterns of blue. For example, observe here, it will appear to be very light blue. Observe here, it will appear to be very dark. This tells you that the depth of the ocean, that in itself varies from one region to another. On an average, the depth of the ocean bottom is supposed to be somewhere between 3 to 6 kilometers from the surface. I will repeat. On an average, the depth of the
এটা কি
oceanic bottom is close to around 3 to 6 kilometers from the surface. So that much depth of water is present on an average. You have the oceanic trenches as well, where the depth can go to the extent of 10 kilometers below the
এটা
surface,
কি
below the sea level, 10
বল
and a
এটা
half
কি
kilometers below the sea level. So
পাম্পকিন
imagine if the height of Mount Everest you
পাম্পকিন মানে
consider, Mount Everest height is only
এটা কি
8.8 kilometers from the surface, from the sea level,
টমেটো
right? Whereas the most
টমেটো মানে
or the deepest portion in the ocean is more than 10
এটা কি
kilometers deep from the surface. So obviously,
বলো
ocean bottom is significantly
এটা কি
varied. Now here, when we talk about the
13
ocean relief, now all these various, now relief feature means what? Relief features, they indicate the topographical
এটা কি
variations which do exist, the various different types of geophysical properties and
এটা
nature
কি
which does exist at the ocean bottom.
ওকে
So when we talk about ocean relief here, so that consists of various different
এটা
features,
কি
such as you have ridges, you have the plain region, you also have the trenches, you have the canyons underneath it, you have the underwater mountains, what we refer to as sea mounts, goyards. So you have various different features. Now, by the way, sea, what do we understand by sea mount? So when we talk about sea mount, so these are underwater
এটা কি দেখো কি
mountains. Okay, that is what is referred to as a sea mount. So, for example,
এটা
let's
কি
suppose
এদিকে দেখ
here
এটা কি
we have the ocean bottom.
লোটাস মানে
Let's suppose here is the top of the sea water
পদ্ম
or the oceanic water.
আনবো ভাই বেটা
Now, if you have a feature of a mountain underneath. Now you have these seamounts, many of them having a height from the oceanic bottom to around 7 kilometers, from the oceanic bottom 8 kilometers, also at a certain depth.
আর রাখতে
Few
পারবো না
of
তুই
them
নিজে রাখ
can rise above the
ওগুলো
surface
আমি
as
রাখতে
well,
পারবো না
but
কেন
many of them
এতদিন ধরে
with a
শিখাচ্ছি
height of 4 kilometers, 5 kilometers, they
এতদিন
continue
ধরে
to
শিখাচ্ছি
remain
নিজে একটাও
underwater.
কিছু আনতে
So
পারছি
you
না
have massive
হ্যাঁ
mountains
এটা কি
underwater as well. So you have these
টিউলিপ
seamounts. Now seamounts are created due to which activity?
এর ওর কোনটা কোনটা
What is
আছে
the activity which
এটা
ends up
এটা
creating seamounts?
এটা
Very good. You
এটা
have the volcanic features, right? That is, whenever you have oceanic convergence in general, that will end up creating
হ্যাঁ
seamounts. Perfect. So here, these are what are referred to as seamounts.
এটা কি
Now, in this
লাইন
case,
মানে
sometimes it also happens that if you have a seamount whose height is not going to increase anymore, whose height is going to lay static, Now, in those situations, the seawater will end up moving around this particular portion continuously. The seawater, the marine water will end up moving continuously. Now, as it moves continuously, then what happens?
আরে এটা
It
আঁকা
will
মতো
carry
তারপর তো
out
সিনো
the
সিনো
process of weathering and
ওরকম
erosion.
কেন করিস আঁকা দিব তো
And due
সব
to that particular process, many of the
এতদিন ধরে
times,
আঁকাচ্ছি
the
তুমি নিজে পারো না
seamount is eroded
কেন
and weathered to an extent
নিজে ট্রাই করো
where you are left with a flat
এটা কি
tableland like surface.
র্যাবিট
Okay, you are left with a kind of a flat tableland like
ওগুলো
surface,
তুই আঁকাবি আমি
and this
পারবো
is
না
what is
আমি
referred
সামনে
to as
ভুলে
a
গেছি
guyat.
তুই আঁকবি ওগুলো এটা কি হ্যাঁ
So, guyat is a kind of an erosional form of a seamount. So, guyat always is the eroded
এটা কি
version, eroded form of
এটা কি প্রথমে কি
seamount.
এটা কি
Okay. Now,
এলিফ্যান্ট
land under the waters of the oceans exhibit
এটা কি
complex and varied
এতদিন
features,
ধরে আঁকাচ্ছি
and
তুমি আঁকাতে
most
পারো
of
না
these features they are created by
দাঁড়া
the
এঁকে
factor
দিচ্ছি তো
of tectonic movement
একা
or
একটা হবে
by
তারপর
the
তো
volcanic activities or even by the erosional and depositional process. It is these processes which end up influencing the type of landform. So here, by tectonic processes, you will observe the creation of oceanic trenches.
এটা কি সালমানা
Oceanic
এটা কি
trenches. Okay,
এটা কি
that is what you will observe. Also, these tectonic
এটা কি
forces. Now, which kind of tectonic movement will lead to the creation of oceanic trenches? Which kind of tectonic forces and which kind of tectonic movement? Yes, it will be the convergent. That is oceanic and oceanic continental. So oceanic convergence will lead to the creation of oceanic trenches.
এটা কি
Okay, oceanic convergence. That will lead to creation of these tectonic landforms. Then you have the volcanic landforms as well. For example, you have the mid-oceanic ridge.
ওট ওট আগে কিছু করবি বলে আগে পড়া হবে তারপরে
Mid-oceanic ridge. Then you have seamounts. So these are created as a result of the volcanic processes. Okay,
পরে
many of the times it is the volcanic processes, as we have studied in the case of sea floor spreading as well, that many
বস
of the times it is the volcanic processes which ends up creating a newer crust, which later on becomes the oceanic bottom. So there, sometimes you can also talk about the existence of oceanic crust. Or rather than oceanic crust, we can have oceanic
হিরো
bottoms. Okay, then you have the depositional and erosional process, both of them.
এদিকে দেখ এইদিকে দেখ হিরো
Depositional and erosional process.
হিরো
So here you have the
এরকম করছি এরকম করে এরকম
creation of
এরকম করে এরকম
continental shelf.
ওয়ান 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 এদিকে
Then you have the
One.
continental slope.
ওয়ান 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 ওয়ান
Then
ওয়ান, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1,
Then you also have, for example, Guyats. So these are the various different features that you find in the ocean relief, which are basically created as a result of. Now you also can consider deep sea plains in this. Okay, you can also consider deep sea plains, where also you'll find a lot of deposits. Okay, so here deep sea plains can also be considered. So overall, you will observe that all of the oceanic features that you see, be it the formation of an underwater mountain, be it the creation of underwater volcanic activity,
কটা 1
be it the formation of oceanic
এটা কটা
trenches,
আছে
be
1
it the
2
formation of submarine
এটা
canyons.
কটা আছে
Now,
1
in
2
all of
3
these cases, you'll find that it is
এটা কটা আছে কম করো
driven by basic geomorphic
4
activities.
হ্যাঁ এখানে
It
এটা
is the
কটা আছে
geomorphic
করো
activities in general
কাট
which drive the formation of these particular
হ্যাঁ
features. So
5
that is
5
the
6 আবার চলে আসছে
dominant
5
portion
এটা
here. Okay. So here, when we talk about it
4
slowly and steadily, let us take a
4
look at each one of them.
4
So here, first of
4
all, when we talk about the division
4
of the ocean floor, the
4
ocean floor is broadly categorized into four major divisions. You have the continental shelf, the continental slope,
4
what is referred to as a deep sea plain or abyssal plain, and also the oceanic deeps or
5
trenches. So this is deep
5
sea plain is
5
what is also referred to as
5
abyssal plains.
5 এদিকে 5
Okay,
5
so here
5
oceanic deeps,
5
they are also
5
referred to as ocean
5
trenches.
5
Now, these are your major
কটা আছে
divisions
স্নেল
of
কাউন্ট করো
the ocean floor. Other than that, you have many minor divisions as well.
5
For
5
example, you
দাও
have
এদিকে
ridges,
1
hills,
2
seamounts, guyats,
3
trenches,
4
canyons, etc.
5
Now, when we talk about
5 এখানে
these
কটা আছে
mid-oceanic
নাট কটা
ridges,
আছে কাউন্ট করো
now these mid-oceanic
1
ridges, they are
2
continuous
3
features. And
হাউস কটা আছে
basically, if you take a look
কোনটা
at
আছে
the
কাউন্ট করো
global distribution of
1
the oceans,
2
you'll find that these mid-oceanic ridges, they are
আবার 1 2
present
3 4
almost
6
in every ocean and they are almost
6
continuous.
6
Their total length underneath the
6
ocean region is
6
close to around 60,000
6
kilometers and more.
6
So think about it.
6
Overall, they have the potential to
6
represent one of the largest
6
hill ranges or
6
mountain ranges or the longest hill and
6
mountain ranges across the
7
planet
এদিকে
Earth.
7
So that is their overall
7
extent. If I take you back to the
7
original map that we saw,
7
so here
7
observe that how these
7
mid-oceanic
7
ridges,
7
they can extend
7
in various different parts and
7
they do extend in various different
7
parts, right, of the ocean.
এই দুটো কোন দিকে যাবে 1 2
All
3
these are your
4
mid-oceanic
5
ridges which
6
are present.
7 8 9 10
Okay. So here
8
you will find them to be
8
extending quite
8
significantly. So overall, their
8
length
এদিকে
is very
এই
large.
যে
Now these are the
1 2
sources of
তারপর 3
divergence.
4
So
5
where
6
you will have the
7
divergence of the
8
plates
9
which keeps on
10
happening.
এই যে
Okay.
8
Now here,
8
let us take a look at each one
8
of them and let us try to
8
understand their
8
basic features. The
8
portions that we have covered in geomorphology
8
already, that is, how
8
is it, for example, that why
8
convergence happens,
9
why underwater volcanoes
9
happen, how is it
9
that you have the creation of an
9
island, how
এদিকে
is it that you observe the
9
creation of a mid-oceanic ridge,
9
how is it that you observe the
9
creation of formation of oceanic trenches.
9
We are not going to go into the details of that
9
once again. So this is basically going to be in those areas.
রেড কটা
I think
হোয়াইট কটা আছে
it will be
1
fine if we
2
just
3 তাহলে
take a
এখানে
look at those
3
particular
লিখবো
portions
ইয়েলো
very
কটা আছে
briefly.
1 2
Otherwise, the
3
newer portions that you are
তাহলে এখানে
exposed to,
লিখবো 3
that is where
ব্রাউন
we will
কটা
go
আছে
for
1 2
in-depth
এখানে
understanding.
2
So
রেড
when
কটা
we
আছে
talk
1
about these
2
oceanic
3
areas,
4
one thing that you would notice
4
is that this
এটা
is
কটা
the
আছে
land
1
portion, first of
2
all.
3
It is not as if immediately where the land ends, the water goes very deep. It is not so. So this
এটা
is
কটা
the
আছে
portion,
1 2
the
3
coast
4
is
5
also
6
what is
7
referred to
8
as the
এটা কটা
shoreline.
আছে অ্যাপেল 1 2 3 4 5 6 7 8 9 10
So this is what is
Orange কটা
the
আছে 1
shoreline.
2 3 4
That is
5
the
6
extent of the
7
water.
8 9 10
But you will observe that the
Sonar কটা আছে
continental
1 2 3
landmass,
4 5
it
6
does
7
not
8
end
9 10
at the
11
margin
12
where you have the presence of water and
Biscuit
where
কটা
you
আছে
have the
1 2
presence of
3
land.
4 5
It
6
does not
7
end
8
at that margin exactly.
টমেটো কটা আছে 1
So the
2 3
continental
4 5
landmass,
6
it
7
does
8 9
extend,
10 11 12
obviously with some amount of slope,
Correctly.
but there is an extension
1
of that
2
continental landmass.
3
Okay,
4
it does extend.
5 6 7 8
Now, this is a
9
region of the
10
shallowest depth.
11
Now, it
12
is where you can
13
have a depth of around
14
few meters, 30
15
meters, 40 meters, sometimes even
16
100 meters or more,
17
maybe
18
600 meters. So that
19
is the maximum depth at
20
which the continental shelves will be.
21
Their extent is variable.
22
Their extent is
23
not constant across the
24
entirety of the planet.
25
So overall, you will
6
observe that in certain
7
areas, such as in the region of the
8
Siberian shelf
29
around Arctic, you have the
30
continental shelf
31
extending up till around
32
maybe more than 1500
33
kilometers into the water.
34
But in certain areas,
35
you will find that the continental
36
shelf is very, very narrow.
37
So that extent of the
38
continental shelf, that
39
length of the continental shelf
40
in itself, that is
41
dependent upon the factor of
2
what do we have
43
as the feature of the
44
landmass in front of it. For
45
example, let's
6
suppose we consider
47
a
48
landmass like this.
49 50
Now let's
এটা
suppose
কটা আছে
water comes
1
up
2
till here.
3 4 5 6 7 8 9 10 11 12
Now
13
here you will find
এটা কটা আছে
that
1
the
2 3 4
landmass
5
has
6
got a
7
kind of a
8
less gradient.
এটা
So
কটা
the
আছে 1
landmass does
5
extend
6 7
quite significantly.
বিস্কিট কটা আছে 1 2
Isn't it?
3
The
4 5
landmass does
7 8 9
extend
10
quite significantly here.
এটা কাপের
But
কটা আছে
let's
1 2
suppose
3 4 5 6
when you
7
have
8 9 10 গ্রিন অ্যাপেল কটা আছে 1 2
the coastal
5
landmass
6
somewhat
7
like this
8 1 2 3
and water comes up till here. So obviously the shelf area won't be very broad. So the extent and the length of the continental shelf
2
is very
3
much
পরে
dependent on the feature
4
of the
5 এর
continental
পরে
landmass near the
6
coastline or the
7 এর
shoreline.
পরে
Generally, you will
8
find in the hilly
9 এর
areas,
পরে
in the mountainous
10
areas where you have mountains across the coastline, there you will find that the continental shelf is very narrow, almost absent. For example, the Chilean coastline, that is the western part of South American coastline. There it is very, very
A
narrow.
for
In certain cases, it is very broad as well.
alligator
So that length ends up varying. Now, this is the region which has got
A
shallow depth. So do you
A
think at this region,
A
sunlight will be available
A
or not underwater?
A
What do you think?
B for beer B
Sunlight will be available?
B B
Yes, it is
B
available. So
B
in
C
continental
for
shelf, you will find the
cat
availability of sunlight
C
because the depth is not
C
significant. So
C
that is why
C D
continental
for duck
shelves, in the case of the
D
oceans, they represent
D
a variety of
D
biodiversity.
D
And these continental shelves overall, you'll find
এটা
that
কি
the amount of biodiversity which
beer
exists,
এটা
that is quite significant.
কি
Overall,
এটা
if you consider the
অ্যাপেল
entirety of the land
এটা
of the aerial spread
এটা
of
না
the
এটা
oceans, the shelf area
grapes
represents only around
এটা
7 to 10% of the
এটা
oceans, but it houses
চেরি
more than
এটা
90% of the biodiversity.
এটা
Why?
স্ট্রবেরি
Because once you have the availability of
E
sunlight,
for
automatically plants
E
will
for
start to grow. And once
elephant
the plants will grow,
E
that will end
E
up producing significant
E
amount of organic matter for
E
the other
F
organisms
for
to survive in that region.
fox
So that is where
F
the shelf region
F
represents almost
F
90% of the
F
oceanic
G
biodiversity.
for
Biodiversity is very
giraffe
significant. Now,
G
in
G
this shelf area,
G
because you have various
G
deposits
H
carried
for
out and also
H
you
for
have
hippo
significant amount of marine organisms
H
which live. Now
H
these marine organisms, they
H
end up dying,
H
and the various deposits which happen on top of them, that leads to a significant pressurization of these organisms. Now marine organisms, when they face pressurization, then what is created as a result of it? What is created as a consequence of it? Very good, Mustafa. So here
এটা কি
it is
টমেটো
the crude oil.
এটা
So that is
Onion.
where when the marine organisms, when they get deposited, the dead marine organisms,
Bell
they get
pepper.
deposited, and then they
এটা
are decomposed under the high amount
ওটা
of
কোথায়
pressure,
অরেঞ্জ?
that forms
এটা
crude
কি?
oil. So these
ব্রকলি।
are the areas where
এটা
crude oil
পি।
deposits are
এটা
significantly to be found. Okay,
এটা
in many parts of the
ব্রিঞ্জাল।
world you will find crude oil deposits in the continental shelf. Even
I
in
for
India, you would have heard
ice
about
I
Bombay High in the
I
region of
I
Arabian Sea, that is
I
present on the continental
A
shelf.
for
Now you would have heard about
E
oil being explored in the region of
jellyfish
Krishna Godavari basin,
J
that is again on the
J
continental shelf beyond the
J
deltaic stretch.
J
So in India also,
K for
we do find crude oil reserves
koala
in these places. So crude oil
K
is to be found in this
K
area.
K
Okay. Now,
K
this continental shelf,
K
after
L
extending
for
for a few kilometers,
lion
that is 100, 150,
L
or 80 kilometers, somewhere
L
like that, suddenly
L
it develops a slope.
এটা কি?
And that
Airplane
end of the continental
ship
shelf, that is referred
motorcycle
to as shelf
taxi
break.
helicopter car truck yacht
This is referred to as shelf break.
আগে এটা কমপ্লিট কর তারপরে
Shelf break demarcates the end of the continental shelf. Now, after
এটা
that,
কি?
suddenly
M for
the depth goes on
mouse
to be significant.
M
So, for example,
M
the continental
M
shelf at max will be how
M
deep? Around 100
M
meters, 200
N
meters.
for nest
Even though if you consider
N
200 meters, that is also quite
N
significantly deeper,
N
right? But here,
N
suddenly the
O for
depth will
ostrich
increase, and the depth
O
can go to almost
O
around 3 kilometers or
O
4 kilometers
P
and
for
beyond
pig
from the surface.
P
So that is the portion of the
P
continental slope.
P
Now,
P
as the sea waves, they carry out their action, and basically the sea water also ends up moving. So as a result of this motion, you will have many of the materials which start dropping
দাঁড়া
down this
আগে
slope.
পড়া তারপর দেখিস
And when these materials drop down the slope, they
দেখিস
eventually get deposited.
is there
So here, suddenly, if the region exhibits a kind of a slope like this, you will find a series of deposits which will also have a slope, but the slope will be not significant. It will be almost very gradual, right? A gentle gradient. So that is what is referred to as a continental rise. Okay, just at the foot of the continental slope,
then
that is referred to as a continental
I love
rise.
that is
And beyond the continental rise,
watermelon
well, there you have the flat featureless plain dotted with few seamounts and goyards here and there. That is what
এটা
we
কি
refer to as the
cat
deep sea plain or
এটা
abyssal plain. It is not abysmal
monkey
plain. Many of you had written abysmal
এটা
plain. It is not abysmal
goat
plain, it is abyssal
sheep
plain. So you
tiger
would have heard about the
bear
English term abyss.
elephant dog Q for
Okay, it is derived
quail
from that. So that is
Q
what gives us
Q
abyssal plain.
Q Q
Okay,
Q
so that is
R
the
for rabbit
etymology of this particular
R
wording. So here,
R
let us take a look at
R
that. So first of all,
R
we start with the portion
R
of the continental shelf.
S for sheep
Now in this map of India,
S
you would observe
S
the
S
bright colored areas
S
across the coastline.
S T for turtle
Bright color,
T
whitish
T
almost, right?
T
Now these are your
এটা কি
regions of
pigeon
continental
duck
shelf.
owl
All these areas
heron
are the regions of
penguin
continental
peacock
shelf.
vulture
Okay, so it is the
parrot
extended margin of each
U
continent
for
occupied by relatively
unicorn
shallow seas and gulf.
U
What do we understand by
U
gulf
U
and what is bay?
U E for
So gulf
vulture
and bay,
E
both of them represent almost
E
a similar feature,
E
where
W
you
for
have a kind of an indenture
whale
in the land. So if the
W
land is like this, it
W
goes significantly deeper, let's
W
suppose here,
W
and then
X
in
for
this area you have the sea,
X-ray fish
right?
X X X
It is very large, not
I
as massive as an
and
ocean or a sea in itself,
food
but
teeth
significantly. Now, if
nose
it has got a
ear
narrow opening,
face
then it will be referred to as a
lips
gulf, and generally, bays you will find
Y
have
for
broader opening. Okay,
yuck
the bays you will find, so
Y
for example, Hudson
Y
Bay, Bay of Bengal,
Y
these have wider
Y
openings. For example, if you
for
consider the Persian Gulf,
zebra.
right? If you consider Gulf of
G,
Mexico, these
G,
have narrower openings.
G,
In both these areas,
G,
in almost all these areas, you will find that water goes into the
robot,
area where the land
duck,
provides them the way.
rattle,
Okay, so that is
teddy
the
bear,
Gulf and Sea. Now,
bug,
here when we are talking about
monkey,
this, another
crane,
aspect. So,
boat.
for example, how many of us we are not aware about isthmus and straits? So let me tell you that initially itself. So when
এটা
we
কি?
talk about an isthmus,
সার্কেল, এটা ট্রায়াঙ্গেল, এটা
so let me
স্কোয়ার,
use another slide if I
রেক্ট্যাঙ্গেল,
can.
পেন্টাগন, হেক্সাগন, ক্রিসেন্ট, স্টার। কমপ্লিট খতম।
I had given you the map pointing for these.
যাও।
Strait of Malacca, the Strait of Gibraltar. So obviously many of you have not done that. So isthmus and straits, what are these? So let's suppose you have, yes, correct. Vaibhav, Karthik, Mushtaba, very good. So let's suppose here you have a landmass. Okay, and another landmass. Okay, so here, when you have two such land masses and these are joined by a narrow stretch of land in between, that is what is referred to as an isthmus. So when we talk about an isthmus, these represent two land masses joined by a narrow piece of land in between. For example, you have isthmus of Kra, isthmus of Panama, isthmus of Suez. These are isthmus, all the isthmus. So this is your land. This is also your land. This is your sea. This is your sea. So this narrow portion, that is your isthmus. Example. I changed the font of it, but then many of you started complaining that don't change the font. So the problem is that the problem is significant. Okay. So here, example, isthmus of Panama. Now I won't be changing font. Okay. So kindly adjust. Isthmus of Kra. Where is isthmus situated? Isthmus of Kra situated? Where is it situated? Yes, very good. In the region of Thailand. That is where you have the isthmus of Kra. Okay. So that is basically the aspect of isthmus that we have. Right? Isthmus of Suez can also be taken as an example. We have built a canal there nonetheless, but these are land masses. Land masses which are joined, and in order to aid navigation, we have built a canal. So isthmus is a narrow land mass which joins two larger land areas and separates water bodies. So that is an isthmus. And what about the strait? Strait is just the opposite of it. So when we talk about strait here, so let's suppose you have a large water body, okay, and then, or let's consider the opposite of it, that you have a landmass here, let's suppose, and you have the presence of another landmass here. And you have the narrow water body which connects them. So this is what is referred to as a strait. It is a narrow water channel which ends up connecting two larger water bodies, right? So Strait of Malacca, Strait of Gibraltar, then you have Strait of Hormuz, then you have the Pork Strait in our case as well. So these are your straits. So example, now these straits, they are very important in global trade. These form very important part of the global navigation and trade mechanism. So they are very, very relevant for maintenance of global trade. So you have Strait of Gibraltar. Where is Strait of Gibraltar situated? Strait of Malacca. Yes, between Spain and Africa. Yes, correct. Spain and Morocco. Yes. Then after that, you also have Pork Strait. Yes, you can consider Pork Strait. Then after that, you have the Bosphorus Strait. Yes, Strait of Hormuz, Bosphorus Strait, all of these. Okay. So here, when we talk about Strait of Hormuz, when we talk about Strait of Malacca, these are very important for global trade. For example, Strait of Hormuz is the place from where you have almost significantly larger portions of oil supply from Middle East, which goes across the world, that crosses the Strait of Hormuz. So maintaining the free flow of traffic at Strait of Hormuz is of vital level of importance. Similarly, when we talk about Strait of Malacca, that is what ensures the traffic movement between the Indian Ocean on one side and the Pacific Ocean on the other. So all the trade which is carried out in the region of eastern part of China, all the goods, materials which are supplied to the eastern part of China, they are basically supplied through the Strait of Malacca. So Strait of Malacca is also very strategically important. Now these form the choke points. Choke points in the sense that, let's suppose, if this is blocked for some reason or the other, forceful or natural, then immediately it can halt all the trading activities. It can bring an endless amount of delay in the supply of materials, and it can economically cripple a particular nation, a particular region. Strait of Malacca is significantly close to the Andaman Nicobar Islands. That is one of the reasons why India is seeking to develop so much amount of infrastructure in the region of Nicobar Islands. Because if you have significant infrastructure in Nicobar Islands, India will also have the capability to extend its reach into Strait of Malacca and influence that choke point. And that choke point is very vital for China. It is in order to bypass that choke point that China has been building the China-Pakistan economic corridor, trying to get access to the region of Arabian Sea via the seaport of Gwadar. So that is the vital choke point that is present in our vicinity. Okay. Now, then coming back to the portion of the continental shelf, so it is an extended margin of each continent occupied by the relatively shallow seas and gulfs. So here in the shelf, sunlight is available. Sunlight is available. Now, if the sunlight is available, that means what? You have photosynthesis is possible, is carried out. Aquatic plants, phytoplanktons, then corals, all of them will survive, and as a result, rich in biodiversity, significantly rich in biodiversity. Okay? Now, it is the shallowest part of the ocean where the depth varies from 30 meters to around 600 meters in general. Now, average width of the continental shelf is around 80 kilometers on an average. In some cases, it is not existent or very marginal, like the coastline of Chile, west coast of Sumatra. Now, it is largest around the Siberian shelf in the Arctic Ocean, example, 1500 kilometers. Now, if I ask you a question that if we, and we have talked about it multiple times in the portion of geomorphology. So, when we talk about the oceanic trench area, now in majority of the cases where you have the oceanic trenches, what do you think in those coastlines? What will be the length of the continental shelf near the oceanic trenches? What do you think? The continental shelf will be wide enough or it will be shallow? Good. It will be very, very short, very, very shallow. So that is totally dependent upon the shape that the continental landmass it takes, the shape that the continental landmass exhibits. So as I told you, wherever you have mountains across the coastline, there the seawater suddenly or the land suddenly gets deeper. So in these areas, the shelf is almost non-existent. But wherever you have the plain region, there the shelf will be existent for a very significantly longer distance as well. Okay. Now, the shelf typically ends at a very steep slope, and that is referred to as shelf break. This is also a source of significant amount of fossil fuels, that is crude oil and natural gas. That is crude oil and natural gas. Okay. Then after this, we come to the portion of continental slope. Now, continental slopes are those areas where suddenly the depth it starts to increase, right? And here the slope means you have a significant gradient. So here you will observe that the depth of the slope ranges between 200 meters to as deep as around 3 kilometers. That is, by the time that you reach the bottom of the continental slope, you are at a depth of 3 kilometers from the surface. Sunlight is not available at all. So, in many of the areas at the bottom of the continental slope, you'll find absolute darkness to prevail. Sunlight never reaches there. Sunlight is never able to penetrate those depths. So, it connects the continental shelf and the oceanic basins. Sometimes you have the presence of the continental rise as well, but that is not always the case. Not in every oceanic region will you find the presence of continental rise as well. It very much is driven by the local topography, the local geographical variation, where is it, how much amount of deposits are carried out. So it is dependent on those particular factors in general. Okay. Now, here you will find the presence of canyons, submarine canyons, and oceanic trenches. Okay. Now, let us take a look at it. What is it that we understand as a submarine canyon? So, here, submarine canyon is very different from that of an oceanic trench. So, if you observe the figure very carefully, you will observe a deeper portion, a kind of a depression like this, with a kind of veins moving in different directions. So that is what is regarded as a submarine canyon. So it spreads right from the region of the shelf, is majorly present in the region of the slope, and extends further sometimes in the region of the continental rise as well. Now, this just by the mere perception and the mere visual aspect of it. No, the numbers of the depth is not. It is not very absolute that this is the depth. You can have a broader idea that this is the depth at which the continental slope exists, the depth of the continental shelf. So that broader idea is more than sufficient. Now here, just the mere appearance of it will give you an idea that how these would have been created. These have been created as a result of erosional activities. But here also, for a very long period of time, you had the geographers differing amongst themselves about the basic formation of these canyons. You had significant amount of differences that many of these oceanologists, many of the geographers, they held the opinion that look, these submarine canyons, they are created due to erosion at the mouth of the large rivers, where you have the large rivers. So as these rivers they flow into the oceanic water, they will carry out these sediments along with them, and these sediments they rub against the sea floor, and slowly and steadily with the passage of time, they would have created large canyons. So here, the evidence of it, the evidence of it overall, observe this map carefully. Now, in this map, I want you to observe this particular area.
বিয়ের প্রতিশ্রুতি দিয়ে একাধিকবার সহবাসের অভিযোগ, কিন্তু ছেলের পরিবার সম্পর্ক
I
মানতে
want you
নারাজ।
to observe these
৭২ ঘন্টা
particular
ধরে
areas
প্রেমিকের
in
বাড়ির
general.
সামনে ধর্নায় বসে রয়েছেন তন্বী। এই ঘটনায় ব্যাপক চাঞ্চল্য ছড়িয়েছে রায়গঞ্জ থানার এলএই
Kiran,
এলাকায়।
my dear
জানা
friend, this
গিয়েছে
is an
প্রেমিকের নাম
English
রিয়াজ
session.
আলী, বয়স ২১ বছর।
Okay, so we are not going to use
তিনি
Hindi in this,
জানান
but you have
দীর্ঘ
a
৪
separate
বছর
link
ধরে তাদের
for
মধ্যে
the
প্রণয়ের
Hindi
সম্পর্ক
session.
রয়েছে। মাঝে
So
মধ্যে তাকে রাত
that is
বেলা
what
ডেকে
I would
পাঠানো
advise you to join if you want to have it in Hindi. Okay, so I apologize for any difficulties, but otherwise, I would also suggest to you that if you are appearing for the examination in English, then always better to improve upon the examination or your language skills in English. If you are appearing for Hindi, then there is no point of thinking about in English. So I hope that is clear. So then, if you observe these areas in particular, now observe these dark portions, these divisions which are there. So these represent your submarine canyons. So that basically proves the first argument that okay, wherever you have these large rivers, there you can have the existence of these particular canyons. So canyons can be created as a result of river action. Okay, they can be created as a result of the river action. Now then, here you also end up finding canyons which are not there where the river exists. In places where you don't have rivers, there also you find canyons. It is true that where you have major and large rivers, you will find the existence of these canyons. That is true. For example, even where Ganga and Brahmaputra they exist, Indus they exist, or Mahanadi, Godavari, all of them they form their own submarine canyons. Mississippi River they also create their own canyons. But significant amount of these canyons are also to be found in such areas where you have no such rivers in existence. So how are they created? So there were a lot of various different kinds of theories which did not make sense. So I'm not going to indulge you in those particular theories. I'm not going to drag you through those particular theories. But just understand the final acceptable theory and the accepted reason that why in these areas where the rivers don't exist, how is it that we experience the formation of a submarine canyon? And that is by the turbidity current, what is referred to as turbidity current. Okay. Now, what do we understand by turbidity current? And how is it that the turbidity current could have created these canyons? So, turbidity, it is derived from the term turbid. Turbid is basically representative of turbulence. So, when you talk about or when you refer to the term turbid water, what do we mean by that? Water which is not calm and where you have lot of disturbance, lot of movement of the particles, dust particles, etc., which is carried out, that is what is referred to as a turbid water, isn't it? So turbidity current, understand how it is generated. So here, let's suppose you have the land and then you have the slope. Let's suppose you have the presence of water body here. Okay. Let's suppose you have the presence of water body here. Now here, when we talk about the movement of the water, now in the sea coast, you would have observed that basically water comes in, goes back, comes in, goes back. Now, every time it does, you would have observed that some amount of sand particles very slowly but steadily, they are carried by the water. Sand particles, small stones, pebbles, sometimes small rock pieces, etc. They are carried by the water. You would have observed that. Now, all this which is carried out, they will be driven down the slope, right? They will be moving down the slope, aided by gravity and the movement of water. They will be rubbing against the sea floor. So this is consistent of particles, sand, stones, pebbles, gravel, mud, everything. It is basically drained down. Now, it is not going to be the case that everywhere, even across the coastline, if ever you have been to a coastal area, you would have observed that if the coastline is, let's say, 2 kilometer, 3 kilometer long, it is not going to be the case that everywhere the intensity of sea wave is the same, right? In certain areas, you would find that sea wave comes further inwards. In certain areas, it remains further away. In certain areas, it has got more force. In certain areas, it has got less force. That is very much dependent upon the topography of the bottom of the coastline. So in certain areas, it might happen that all these, they are channelized, all these, they start moving. Now, that movement of mud, sediment, sand, stone, pebbles, rock particle, gravel, etc., that kind of a movement, that is what is turbidity current. Now, this movement, aided by water's movement and aided by the slope, it can sometimes gain the speed. This movement can have the speed of almost 45 to 50 kilometer per hour. So you can imagine, right? It can have that high a movement. So when you have all these particles rubbing against the seafloor continuously over a passage of many years, can we imagine a situation where they will create a kind of a crack or they will rub the seafloor away? Now, once you have the creation of a crack or a depression, then automatically all the various different sand particles, etc., everything from around will also start draining from that only. That is where continued erosion happens due to continued movement. So, continued movement leads to erosion. Once the erosion happens, then over a period of time, you'll find that to be deepened. Because obviously, if let's suppose this area is like a plain region, now if this area is plain, materials can move equivalently across all these areas, all these stretches. But if let's suppose you consider the palm of your hand, and here you consider the indentures made between your fingers. Now, if it starts moving, the materials, they start moving from here, you will find that automatically the materials, they are driven at these particular depressions, and that is where they will continue to flow, and they will deepen that depression. So that is how it creates very narrow, very long erosional channels which have certain bifurcations and branches which drain out, and that is what we refer to as the submarine canyon. Okay, so that is the case of the submarine canyon creation. So submarine canyon, again I will repeat, can be created by two ways and two processes. One is the mannerism, or one is the way in which you will observe that these submarine canyons, they get created at the mouth of major rivers, because as the rivers, they empty themselves into the water, so there you will find that the sediments carried by the river and the silt carried by the river, it drags itself across the sea floor, creating some indentures, and further multiple hundreds of years later, you will have the creation of a depression. Many hundreds and thousands of years later, you have the creation of a submarine canyon. Second reason is the existence of turbidity current. And turbidity current that creates these depression in these areas by the movement of the sand particles, the rock pieces, all these pieces when they keep on rubbing against the floor. That is where in certain areas they will create that indenture that will further deepen. So in hundreds and thousands of years, you have the creation of the submarine canyons there as well. Okay, so that is basically the existence of the submarine canyon. Then we have the deep sea plains. These are the bottom portion of the ocean, not the deepest portion of the ocean. The deepest portion of the ocean floor is the oceanic trenches, but these are the bottom areas, the bottom portion. So when we talk about deep sea plains, these are oftentimes, first of all, these are simply the oceanic crustal region where you have deposits of sand, mud, ooze, etc. And that is what forms a flat, featureless, plain like feature. Now, here in certain areas, you will have the periodic presence of underwater mountain like seamounts, coyotes. Otherwise, you'll find them to be flat, featureless. So, flattest and smoothest region, average depth around 3 to 6 kilometers, and fine graded sediment like clay and silt are present. So, at these depths, here, do you think there will be availability of sunlight? No. So these are the regions in permanent darkness. Regions in permanent darkness. Okay. These are the areas which end up experiencing the condition of permanent darkness. Okay. So here you have no sunlight available, so no photosynthesis can be carried out. So biodiversity is comparatively lesser. You have lesser extent of biodiversity. And also here you will generally encounter that you have very specific kind of species which inhabit this region. You will study it in environment as well. Very unique and specific kind of species which inhabit this region. And that is what we refer to as the benthos. Unique species living in the area, they are referred to as benthos. You will find that they have their own natural adaptations that they carry out. For example, you will find that their eyes are particularly larger in order to help them to be able to look into the conditions of permanent darkness. You'll find that their skull is very hardened. The body is very, very thin because at that particular depth, the amount of pressure will be very high. At the depth that we are talking about, that is at the bottom, here the pressure is so high. Just to give you an idea, that for example, if you think about it, and the large submarines that you have, the very large and massive submarines of the various different countries, they have their ceiling limit, that is they cannot go beyond that depth. So there, most of the submarines you'll find they can go up till a depth of around at max 1 to 2 kilometers. It is only in very rare cases that you will find a certain submarine to be able to go beyond that depth. So if you consider any of such larger submarines, now if let's suppose you have an accident and all the submarine disasters which happen because of this reason, so they get to the ocean floor. Now the pressure is so high from the water around it that the submarine can be crushed like a tin soda can that you have. Soda cans that you buy from the market, how you can crush it with your palms. Similarly, imagine the pressure from the water is so high that the submarines can be crushed. So that is the huge pressure. So obviously the species living in this region have to go through their own set of modifications, their own set of adaptations as well. Now here also you have to understand that in this particular depth, not many things can exist. So biodiversity is also limited. But more or less, here you also have the factor that we have not been able to explore much more. So that is where our knowledge about the abyssal plain is also restricted. Yes, the implosion of the Titan that you would have seen. Yes. So that is the feature here. Then after that, we come to the oceanic deeps, or what are referred to as the trenches. Okay, so oceanic deeps or trenches. So when we talk about oceanic deeps or trenches, these are the deepest portion on the ocean sea floor, ocean floor or ocean bed also. So these oceanic deeps, they can have a depth of more than around 7 to 8 kilometers from the sea level, sea surface and the sea level. So how do they get created? So basically, here you will observe they get created due to convergence or tectonic movement. Now, I understand many of you have joined us very recently and you have not done the portion of geomorphology. So, I would request you kindly revise that portion of geomorphology to understand these particular aspects. After this, you won't find much of a reference to geomorphology, etc. So, these aspects you can revise or repeat from the portion where we have covered plate tectonics in significant detail. Okay, so here convergence of oceanic floor. So either it is oceanic continental or it is the oceanic, either of them. Okay, so here when we talk about any of the sea flow or any of the plate movement, let's suppose this is the surface of water. Here you have underneath that water, let's suppose you have the convergence which is going on. Okay. Now, as one plate is subducting underneath the other, observe there's a kind of a depression, narrow depression like feature created. That is what is an oceanic trench. So, it can be created as a result of oceanic continental convergence. It can also be created as a result of oceanic convergence. Okay, it can be created by either of these processes. So that is the case of the oceanic deeps or the trenches in general. So overview if you want to have, so observe continental shelf, the shallow portion, then followed by slope, then you have abyssal plain, you can have sea mounts, and if these sea mounts they extend significantly above water, they are referred to as islands. Then you have the trenches in certain cases, then continental rise in many of the areas. Continental rise is not consistent in every ocean. Continental rise is created purely by deposit. When you have the seawater carrying those sediments, the particles, sand particles, etc., now they drain down or move down the region of the slope and they get deposited at the foot of the slope. That is the continental rise. Okay, so that is basically the entire morphology, entire topography of the ocean floor. Okay, now after this we move to the portion of ocean temperature, and we will take a look at the variations in ocean temperature. How is it that the ocean temperature varies? Why is it that the ocean temperature varies? Let us take a look into that. So when we talk about the oceanic water, what is the prime source of heat for the oceanic water? Where is it that the oceanic water receives its heat in majority? Perfect. It is going to be the sunlight, solar insolation, right? So, that solar insolation is the prime source of heat, right? In the case of the oceanic water, let's suppose you consider an ocean. Yeah. So, that sunlight, that is going to be your prime source of heat here. Okay. Now, sunlight will be available only up till a certain depth. Beyond a particular depth, sunlight won't be available at all. Right? So, the depth up till which sunlight is available, that is what is referred to as the photic zone. And beyond that depth where the sunlight is not available at all, that is what is referred to as the aphotic zone. So that is where the concept of photic and aphotic that comes into picture. So here, the prime source of heating is the solar energy. The process of heating and cooling of the oceanic water is slower than that of the land. Okay, so that is where you have the concept of the photic and aphotic and the heating and cooling. Generally, I would tell you the region. So when we talk about photic zone, regions where sunlight is available, sunlight is available. Aphotic zone, region where sunlight is not available. Okay, that is the photic and the aphotic zone. Okay, now let us take a look at the various different factors, because if you take a look at the distribution of oceanic temperature, now this oceanic temperature in the horizontal aspect from one region to another, it will vary. For example, the oceanic temperature that you observe around the region of equator, that oceanic temperature will be much warmer than what you observe, let's suppose, in the region around the poles. It will be much colder. So that oceanic temperature is influenced by multiple factors. First of all, we will take a look at the horizontal distribution. That on what factors? Remember, in climatology also we had taken a look at the factors which influence the horizontal distribution of temperature from one region to another, where we had taken a look at factors such as altitude, factors such as the amount of solar insolation, inclination of the planet Earth on its axis, ocean currents role, the prevailing winds, distance from the sea. So those were the factors which would influence the air temperature from one region to another. Now, similarly, let us take a look at the factors which will end up influencing the oceanic temperature from one region to another. So first is the latitudinal extent. Now, when we talk about the latitudinal extent, we know that the lower latitudes, that is the region around equator, that is where the amount of solar insolation received is much higher. Now, if the amount of solar insolation received is higher, obviously you will find that there is a greater amount of heat which is received, the greater amount of heat which is attained. So, in terms of latitude, surface water temperature decreases from equator to the pole because of insolation. Why? Insolation is maximum closer to the equator. So, insolation is maximum closest to lower, or rather at lower latitudes in general. Okay. What is not clear about latitude? Point that out. What have you not understood about latitude? Because we have discussed the portion of latitude earlier in the area of insolation as well, in the area of temperature distribution as well. So I hope we understand what do we mean by latitude, right? So insolation is maximum at lower latitudes and reduces polewards. Polewards means, is the meaning of the term polewards not understood? Is that the sticking point? Polewards refers to as you move towards the poles. That is the meaning of. So you would have heard the term towards. that person is going towards his home, so that is towards, so polewards, that is moving towards the poles. So that is where temperature reduces. Then, unequal distribution of land and water. Now, when we talk about oceans, now they will also get influenced by the heating of land and the nearby areas. And the nearby areas of the land, when they get significantly heated up, they will end up extending that heat to the nearby water bodies as well. So that is where oceans in northern hemisphere, they have more contact with land compared to the southern hemisphere. That is where more heat is received in the northern hemisphere. More heat is received in the northern hemisphere as compared to the southern hemisphere. Why? Because northern hemisphere is dominated by land mass, so the land will get heated very quickly and much more intensively. So as the land gets heated up, it will extend or subtend that heat furthermore. Okay, now after this, here, you also have a significant role to be played by the prevailing winds. Prevailing means the existent winds. So the winds can be onshore in an area, the winds can be offshore in an area as well. Right? So you have the onshore winds, offshore winds, those phenomena, they do exist. So we have seen about the phenomena of upwelling and downwelling as well when we were talking about the Enzo cycles. So what do we mean by onshore and offshore? So let's suppose if you have the land region somewhat like this, let's suppose here you have the water body. Now, if the winds are blowing like this, so land to sea, that is offshore. Then sea to land, that is onshore. Wherever you have offshore, that will drag away the surface water and it will bring the cooler subsurface water to the top. And this is the region where you will experience upwelling. That is where you will experience upwelling. And we have seen that upwelling ends up reducing the surface water temperature. Okay, so that is where when we have upwelling, so upwelling will always end up reducing the temperature of water in that area. So in many of the regions where you experience upwelling, the temperature of the sea surface water is considerably lower. Okay, so that is upwelling, decreases the temperature. Now, when you have onshore winds, they will drag the surface water, force them downwards, and that is downwelling. So, downwelling will mean all the accumulation of the warm water. So, onshore winds, they carry out downwelling. Out downwelling. And that is here increases the temperature of surface. I hope that is understood and that is recalled as well. Okay, so that is your factor of upwelling and downwelling. Okay, now after this, we also have a significant role which is played by the ocean currents. Now, when we talk about ocean currents, now just like in the case of land, you have the movement of the winds which can influence the temperature. In certain area, if warm wind comes into play, that will lead to increase in temperature. In certain area, if the cold wind comes into play, that will lead to the reduction in temperature, isn't it? So here also in the case of ocean currents, you will have the role played by the similar manner, in which in a region where you have the cold currents coming in, that will reduce the oceanic temperature in that area. In certain areas where you have the warm currents coming in, that will in a way increase the temperature of that area. So warm ocean currents, They raise the temperature in colder areas, and the cold currents decrease the temperature in warm water areas. We'll study about the ocean currents in significant detail very soon. So don't worry about it. We'll study about it in a lot of detail. Now, here, when we talk about these, so you can have the example, North Atlantic drift. Drift raises the temperature of northern portion of Atlantic and keeps it ice free for, or rather through the year, because North Atlantic drift, it is an example of warm current. Then this is the case of the Atlantic. Then you have in the region of Pacific Ocean, you have the very cold um, Peru current, Peru-Chile current, that reduces the temperature. So we will take a look into that as well later on when we talk about all these oceans and the ocean currents which exist in all these areas. We'll take a look at that as well. Now here, you also have the factor which you have to consider, whether the water body or the seawater that we consider, whether it is surrounded by land or are we talking about open oceans. For example, open oceans such as the Atlantic, such as the Pacific, they are open, right? But let's consider the Mediterranean Sea. Now, Mediterranean Sea is surrounded by land from all sides. Now, in the lower latitude, the impact of that land will be different as compared to the impact of land in the higher latitudes. What do I mean by that? So, for example, when we talk about the lower latitude, now in the lower latitude, the land will get heated significantly on an average throughout the year. The land will have higher temperature. So, if I ask you if this is the Mediterranean and this is the at the same latitude, let's consider the Atlantic as well. So, at the same latitude, if I consider, then which will be much more warmer, Mediterranean or Atlantic? What do you think? Which will be hotter? Always Mediterranean, isn't it? Because it is closely bordered by the land. So there you will have sudden rise of temperature. Whereas across the Atlantic, as it is an open ocean, you will have a gradual variation in temperature which is experienced, isn't it? So here you will have a gradual variation in temperature. Here, the impact of the land will create a sudden rise in temperature. But if we consider, let's suppose, the Gulf of Bothnia or the Baltic Sea, that is in the higher latitudes. Now, in those stretches, here the land will get very cold. On an average, the land temperature will be very high. So, what do you think will be the temperature in comparison to the open ocean? The temperature will be very low, right? Because of the cooling of the land, that will induce cooling of the water as well. So, at lower latitudes, enclosed seas have higher temperature because of the influence and heating of the land due to the heating of the land. Okay. Whereas at high latitudes, it is the high latitudes means closer to the poles. So closer to the poles, there is cooling in general. The regions are colder. So when the regions are colder, always land will be much colder than water because the land is able to lose heat at a much quicker and faster and continuous pace as compared to the water body. So at high latitudes, open seas, they have higher temperature and closed seas, They are colder. Enclosed seas are colder. Enclosed seas means which are surrounded almost on all the sides from the, or which are surrounded very closely by the land masses. Open seas means they are open and there is a kind of a larger ocean that we are talking about. So enclosed seas are colder. Why? Because land gets colder in higher latitude. Okay, so I hope that is understood. Why higher temperature near the poles? Higher temperature in comparison, it is in comparison to open seas and enclosed seas. You are holding it in comparison. So overall, as you move from equator to poles in the ocean, the temperature will reduce. But then what about these enclosed seas such as Mediterranean Sea, such as the North Sea, Gulf of Bothnia, all these? So in that region, you will observe that the enclosed seas, they are much colder than the comparison to the open ocean in the higher latitude. Whereas in the lower latitude, closer to the equator, the enclosed seas are much more hotter, much more warmer. Is that understood? Okay. Right? Okay, I understand where you have this doubt. Jalendra, that is what is happening. Everybody is asking question in live. So let me write it down. In comparison, low latitude. I thought you will be able to deduce that, but nonetheless, low latitude in comparison to open ocean, enclosed seas are much warmer as the solar insulation heats the land nearby. Then high latitudes. In comparison to open oceans, enclosed seas are much colder due to influence of nearby landmass, which becomes cold. Is that now clear? Right? Is that now clear? Perfect. So all those of you were saying that this slide is wrong, this is written in incorrect portion. And so I hope that now that portion is no longer doubtful. Okay. Now, after this, This is the representation or the variation in oceanic temperature that you will experience in various different stretches, various different parts of the ocean. You will experience this kind of a variation in temperature. So observe certain points here. Observe how the Bay of Bengal is significantly and comparatively warmer as compared to the Arabian Sea, because the Arabian Sea is much larger of water body as compared to the Bay of Bengal. Bay of Bengal is closely surrounded by land, whereas Arabian Sea is much wider. Then observe here, if you can notice carefully, are you able to see or spot a kind of a pattern here at the equatorial region? Are you able to spot a kind of a pattern of warm water here? Here also, are you able to spot a pattern? So, which phenomena does it indicate? What does this indicate? These are the tropics, very good. Near equator, very good. Equatorial heating. But why, if there is equatorial heating, why is it that here you have more warm water? In the western portion of Atlantic, you have more warm water as compared to the eastern. Komal, beautiful. Very good, Komal. Abdullah, perfect. Yuvraj and Ridicula, correct. Vaishali, correct. It is basically the presence of the trade winds. If you can spot it here, the trade winds will blow, and observe how they are dragging the warm ocean water. All that warm ocean water will accumulate here and then will be forced here. Here also you will observe that the trade winds, so all those who had pointed Enzo, you are also correct. So here also you will observe that the trade winds, they are carrying that surface water, and you will find the accumulation of surface water across Western Pacific. So that is what tells you that oftentimes the wind movement which happens over these oceans, they are also able to drag the surface water away. Okay, over India it is not very prominent, because over India the trade winds themselves, they are not very continuous, are they? We have seen just yesterday that over India the wind pattern changes between the various seasons. You don't have a continuity, so that is why over India you don't have that kind of a pattern. So here you will observe wherever there is a continuity, there is a kind of a pattern which develops, right? Now, after this, we come to the vertical distribution of temperature. That is, how is it that temperature varies as you start moving deeper from the surface? Now, we have already seen that the temperature is determined by the amount of solar insolation, which is a main driving factor. Solar insolation, if it is higher in a region, that means obviously greater amount of heating. And as the intensity of insolation reduces, the amount of heating also will reduce, isn't it? So that is where in the photic zone, you will in general experience higher temperature. As you move into the aphotic zone, that is where the temperature reduces significantly. Here, so that is where, let's suppose, we consider the water, the ocean. Let's suppose. Let's suppose this is the ocean depth. Now here, let's assume this is the maximum stretch where the sunlight is able to penetrate. Maybe 1 kilometer from the surface. Generally, it is 400, 500 meters from the surface. Let's assume 1 kilometer in certain cases. Now, as the sunlight is getting here, now the temperature at the surface will be hotter. In general, we are considering the lower latitude for reference in this case, so that it is easier to understand. In general, the lower latitude is what we consider. So here, if I have to represent this on a graph, the graph is visible to everyone. if I have to represent this on a kind of a graph, let's take this as the point of temperature. Let's take this as depth. This is the surface. This is the bottom. So here, at the surface, in the lower latitude, that is around equator, the temperature will be highest. Temperature at the equatorial or the tropical oceanic water, the temperature on an average is around 24 to 25 degrees Celsius. That is the average temperature that you get. So it might have certain variations here and there, but the average temperature will be around 24, 25 degrees Celsius. So let's suppose here you have the temperature at surface. Now, as you go at the depth, let's suppose I am here now. Now the temperature will reduce, isn't it? The temperature will reduce ever so slightly, but not majorly because we are not going at a significant depth. But the temperature will reduce nonetheless. It will keep on reducing. Now, once you reach this portion, light reaches this portion, doesn't go any further. Now, at this particular area, there will be a zone of transition. It is not as if here light is existent and here it is completely dark. That won't be the case. Slowly and steadily, the intensity of light will keep on reducing, reducing, reducing till it will get so dim that it is dark. You have that diffused zone. You have that zone of transition which exists, isn't it? So here, when it goes here, in this zone of transition, what do you think will be the change in temperature? You are coming from a region where sunlight is available, moving into the region where it is always darkness. So the temperature fall, can we say it will be drastic? It will be sudden? Can we say that in this zone of transition, there will be a sudden reduction in temperature? Right? So that is where in this zone of transition, you will observe sudden reduction in temperature.
যেগুলো আছে ওগুলোকে
What
ভালো করে
after
দেখো
it reaches here or here or here? Now all these areas are dark. Now here, the role of solar insolation goes out of the window. It is not as if that here if you are here, then you will have the impact of the sun. And if you go further 10 meters down, no impact of the sun. No. The areas which are perpetually dark, they have remained in darkness for millions of years. Now there, the temperature will largely be consistent, isn't it? So here, after going to a depth, the temperature will remain consistent. Right? And that temperature is roughly, you will observe, around 3 to 4 degrees Celsius at the bottom. It is not as if at the bottom the temperature will be minus 20, minus 40 degrees Celsius. Temperature at the bottom is largely around 3 to 4 degrees Celsius. Why? Why doesn't the temperature go below freezing point? Or why doesn't the temperature at the bottom, where the sunlight is not available ever, why is it that the temperature is not around 0 degrees Celsius? Think about it. There are a couple of reasons for that. The first reason is that there is a significant amount of pressure which is induced by kilometers wide or kilometers thick water column. So that pressure which is induced, that automatically along with it produces some amount of heat, right? That is the hydrothermal gradient. So that produces some amount of heat. Secondly, water, when it is compressed, will have its maximum density when? Water's maximum density occurs at what temperature? At 4 degrees Celsius. If you cool water below 4 degrees Celsius, if you cool water and make it into ice, its volume increases. Because ice is the or water is the one of the only few examples where the solid occupies a larger space. Due to development of crystalline structure, we are not going to go into that. But water's density, that is where it is going to experience maximum compression, is going to be 4 degrees Celsius. That is where the temperature is almost consistent between 3 to 4 degrees Celsius. So here, you will observe that initially the temperature is consistent at the surface. Now, as you start going to the depth, you enter into that zone of transition where you are entering from a region of, so you enter into, initially it is consistent, then you enter into that zone of transition where above it you have the photic, below it you have the aphotic zone. So as you enter into the zone of transition, you will observe the sudden reduction in temperature, and then it is consistent in the aphotic zone. It is almost consistent in the aphotic zone. So that is where it is around roughly 3 to 4 degrees Celsius. So that zone of transition where the surface phenomena goes out of the window, because all these phenomena that we have seen, latitudinal extent, enclosed ocean, enclosed sea, open sea, impact of the ocean current, then unequal distribution of land and water, all these prevailing winds, all these phenomena, they are not carried to the bottom of the ocean. They are restricted around few hundred meters from the surface of the water itself. All these are surface phenomena. At the bottom, the ocean ends up representing a kind of a consistency in temperature, density factor, which it has exhibited for a very long period of time. So generally, you will find at the bottom there is a greater amount of consistency. So here, so the region where there is a rapid decline of temperature, which happens, that is what is referred to as thermocline, or the change in temperature. So here, that is the observed in the boundary region or the zone of transition that can extend from 100 to 400 meters below the sea level, can extend downwards. Generally
See,
extends
there is
between the photic and aphotic zones. Okay. If we go to underground area of land and if we go to the depth of sea, in both conditions, what is the temperature? At that depth, around 4 to 5 kilometers, the land starts getting warmer. So land temperature at the same depth of 4 to 5 kilometers, land will be warmer as compared to the bottom of the sea. Okay. So here, that is the aspect of thermocline. Now we introduce ourselves to the portion of oceanic salinity. So very briefly, I'll tell you what do we cover by this or what do we mean by this, then we will enter into the break. So salinity means what? Salinity refers to the salt content. If ever you have been to a coastal area, you have taken a swim in the sea water, oceanic water, and sometimes when it goes in, you feel that kind of a salty taste. So seawater, oceanic water, that is enriched with the salt content. That consists significant amount of salt. Now, salt does not only mean NaCl or the table salt that you consume. It also means, for example, CaCl2, CaCO3, various different types of are present. Now, how are they supplied? They are supplied by volcanic events, volcanic activities that happen, dissolution of rocks from the coastal areas, marine erosion which happens, all of them, they continue to bring. Then you have many of the marine organisms, they will also secrete salt. So all of that gives significant amount of salts into the oceanic water. Generally, the amount of salt on an average is around 35 grams per kg of water. Okay, that is the average amount of salt present. 35 grams per kg of water. So that is why salt, we can say that it is 35 grams per 1000 grams of water? Right? Grams will cancel out each other. So that is why salinity is represented in parts per 1000. So that is 35 parts per 1000 of water. Okay. We'll talk about this salinity in detail. Before that, we take a break. And then after that, so we take a 15 minutes break today. And we'll be back by around 7. And after that, we will come back and we will continue with this portion. Okay. Kind of compulsions and requirements as well. The basic minimum that should be consistently done on a daily basis is whatever has been covered in the morning session should be revised. Whatever has been covered in the evening session, whichever subject you are attending, should definitely be revised. And along with that, you need to find out time for the current affairs for that day as well. Do this basic work. Okay, don't try to explore a lot of things, but just whatever has been done in the class, ensure that after the class, with the help of either the annotations of the PPT or the recordings, or maybe the additional reading materials or your own notes, revise that so that it stays in your brain, right? It stays in your memory. What is the general tendency that I find amongst many of the candidates is that when they join the session, then they ask for the please provide me with the annotations of the PPT for yesterday. Please provide me for the annotations of the PPT for day before yesterday. Now, obviously, there is no revision which is being carried out. So there you are simply sitting through the classes. You are simply a mute spectator. And I will also be as blunt as to say that simply sitting in the classes, if that would have helped people clear the civil services examination, then you would have many people clearing the examination. Unless and until you do that effort from your own side, this is an examination which weeds out the weaker people. So, in the sense of who don't put in the hard work. So, just do these basic works, more than sufficient. Is monthly magazine for current affairs for geography come UPSC sufficient? Yes, for current affairs, yes. And Palak, is it necessary to read the Hindu or Indian Express only? Can we not shift to Hindustan Times? Why do you want to shift to Hindustan Times? Because it is much more interesting, because it has much more better images. Why people suggest to you about Hindu and Indian Expresses? Because they carry the meaningful articles more relevant to the questions being asked, the analytical kind of questions being asked in UPSC. So that is where people will suggest to you about the Hindu or the Indian Express. Try to restrict to that. Times of India, you can study, you can read whenever you want some entertainment in your life, whenever you are feeling a bit bored in your life. So then you can always go for Times of India. But Times of India is purely for only entertainment purposes. Which political leader has said what about another political leader? Whether you have had a particular event in any part of the country. So those kind of entertainment and masala news, as I refer to them. So for that, you can study the portion of Times of India. But for civil services preparation, either the Hindu or the Indian Express, any of them. Okay. after classes and revision trying to solve prelims, is it better? So not every day will you get enough content to be able to solve prelims questions. So basic thing is that revise the classes on a daily basis. Where does the IT season lies in September as it is equinox? In the case of Indian subcontinent, it is still very much in the portion of the central part of India itself. Okay. Yes, Shalja, that is correct. Yes, Mustafa, that is what. If you want to know more about Bollywood celebrities, if you want to know more about what is happening in the metropolitan areas and the fast paced life, the page 3 kind of news, if you are interested in, Times of India is good. Okay. And for geography options, should I focus on extra sources of current affairs? Yes. Down to Earth magazine is something that I recommend to everyone, even for the portion of the GS. Down to Earth magazine is something you should always be very, very religious with. Okay. Right. And now we come to the portion of oceanic salinity back again. So, when we talk about oceanic salinity, it represents the amount of salt contained in the oceanic water. So, let us simplify this. Let us break this down. So, let's suppose you have a sample of oceanic water. Now, this sample of oceanic water will obviously consist of water molecules, lot of water molecules, right? Lot of various amount of water molecules will be present here. Now, in the spacing which is available wherever it permits, you will have certain particles such as calcium, such as magnesium, such as carbonate, chloride, sodium, etc. Now, these represent the salinity. So, the total amount of salt which is present in the any sample or 1 kg of oceanic water, that is representative of the oceanic salinity overall. Okay. Now, here, the total content of dissolved salts in seawater, that is what is referred to as the oceanic salinity. It is calculated as the amount of salt dissolved in seawater of 1 kg or 1000 grams. What is the total amount of salt which is prevalent? It is expressed as parts per thousand or ppt, which is represented by the symbol like this. Okay, so this represents parts per thousand. Now, the salts are what? These are consisted of various ions such as chlorine, sodium, sulfate, calcium, all of these. They are the dominant salts which are present. Now, what are the sources from which or why is it that the seawater is saline? Where is it that the seawater gets all the salt content? So basically, let's suppose you have a volcanic eruption. Volcanic eruptions can happen underwater as well. Volcanic eruptions can happen above the water as well. So these volcanic eruptions, whether happening underwater, whether happening on the surface, and then depositing themselves, so they will consistently be adding these salts. Right. Other than that, some amount of, very little amount of carbonate and calcium in particular will be added by the river as well. River water is considered to be fresh water because in the river you will not find significant amount of salt which is present, right? But ocean is where all these salts are deposited over a period of time. Then also at the region where you have the interface, that is, you have the seawater interacting with the rocks here, in the region where you have the seawater interacting with the rocks. So, marine erosion can happen. Many of these portions of the rocks, they can get dissolved in water. So, they will also add to the salinity. So, all these activities, all these processes, they keep on adding salt continuously into the portion of water. So, that is where the seawater gets its salt content. So obviously, it will not be consistent across the various parts of the ocean. It will be variable because it will be dependent upon where how many rivers are coming in. Because when you have a river moving, river will always end up adding more amount of fresh water as compared to the amount of salt and sediments, because river water in general is fresh water, right? So it varies from one region to another. Now here you might have a pertinent question or a simple question arising out of it in your minds. Obviously UPSC will never ask this, that all these salts, they keep on getting added into the ocean, and we do know that the oceans, they have been in existence for a very long period of time, for billions of years. So why do we say still that the salt present is around 35 parts per thousand? Why hasn't the amount of salt increased substantially? That is because over a period of time, many of these salts, they will combine to form larger particles. And when they combine to form larger particles, first of all, immediately they will start dropping and depositing themselves at the bottom of the sea floor. And also, to add on to that fact, you will find that at this point, here, you have the dissolution which is carried out, but also simultaneously, due to the action of, let's suppose, the sea waves, let's suppose the wave action that is created. Now, whenever the wave strikes the coastline, whenever you have a condition where the wave strikes the coastline, if ever you have witnessed this in the images, in the videos, or in your real life experience as well, if you stand close to that water, lot of that water after hitting the coastline, it is spray, right? It hits the coastline with much amount of force, and there's a spray created. Now many of those spray particles are very, very small. They consist of salt included in them, so that is then carried away by the wind as well, right? So many of these salts will be utilized by the organisms as well. So that is how, over a period of time, the salt present is also utilized and lost from the sea surface. That is why, on an average, the seawater is able to maintain its salinity level. Now, here, if you take a look at the proportion of the various different types of salt present, the most dominant salt which is present is NaCl, or sodium chloride, something that we consume in our everyday diet. Now, that sodium chloride consists of a whopping 78% of the overall salinity. That is why, when by accident or by mistake you consume that sea water, that is where you feel that immense salty taste. It is given by NaCl. Then you have magnesium chloride, then you have magnesium sulfate, calcium sulfate, potassium sulfate, calcium carbonate, magnesium bromide, and so on. So that is where you will experience all of this as well. Okay. Overall, for your prelims, you don't need to be learning all of this. But for your prelims, what I would suggest to you is the first four. Not in terms of their exact proportion, but the first four in terms of what is their order of presence. That is sodium chloride, magnesium chloride, then magnesium sulfate, and calcium sulfate. So these first four should be kept in mind. Okay, that first four is important and relevant for your prelims. Okay, relevant for prelims. Okay. Now, only the first four you need to keep in mind, and the rest you can forget. And here also, just the type of salts which are constituted in the first four. That is all. Now, after this, we come to the portion on what are the factors upon which the salinity varies, the surface salinity that we have. So that at the level of the surface, salinity is not consistent in various parts. It varies. It varies whether on in some region you have evaporation which is happening. In some region, if you have more amount of precipitation or rainfall, melting of ice, freezing of water into ice, then influx of river water or the emptying of the river water in those areas. So these are the factors upon which the salinity ends up varying from one region to another. Now, overall, rather than learning all of this and learning that
Devi,
evaporation leads to a increase of salinity or decrease in salinity, precipitation leads to a decrease or increase, let us understand this with the very basic concept that what happens in the seawater, whether
hey,
any
चलो जल्दी
event will
बोलिए.
lead to the net addition of water molecules or the net removal of water molecules. Net means that in total, that seawater is impacted by the removal or addition of water molecules. With that, we will understand whether the salinity increases or decreases. Let us see how.
Daddy.
Okay. So, here, when we talk about the salinity variation, salinity variation, that is addition and removal of water.
पढ़ दे खुले पढ़ दे देखते हैं.
Proportion of salt is higher. What do you think?
दे देखते हैं
In the
रखी.
second case, right? So here, can we say salinity increases the salinity in general increases. Why? Because there has been a removal of water. Removal of water. Now, let's suppose you have water in a region and you have the water, the temperature is very low. The water freezes. Let's suppose in the polar areas. When the water freezes, so
बांग्ला
when you have the
पासे
freezing which happens,
बांग्ला
majorly it will be the water
बांग्ला
molecules which will get frozen.
बोलो
Salt will also get frozen, but in lesser quantities. More
पासे
amount of water is what
बांग्ला
constitutes ice.
एक
Nobody will tell you, or even your common sense will tell you, that when you consider an
चार
ice, the
पाँच
predominant part in ice is water. It might have one or two particles of salt, but majorly it is
बोलो
consisted of water. So,
टू
can we
टू
say that whenever
टू
you
टू सा
encounter
फोर
a freezing action, there
सिक्स सा
also
सिक्स
you will experience removal
फोर
of
सा
water
एट
molecules? Right? That will be a correct
फाइव सा
assumption to
टेन
make. So, this is also observed.
ट्वेल्व
So, evaporation
हेलो
and also
सिक्स सा
observed
टेन
in the case of freezing.
और तो साढ़े
Also
दो
during
पाँच मिनट
freezing. Okay? Because whenever in a region where you have the presence of salt and water as well,
टू
so
टू सा फोर
majorly due to freezing, the
टू
water
टू सा
molecules will get frozen. The
फोर
salt will get left behind. So when the salt gets left behind, so in that oceanic water sample now, you will
ऑर्डर
have
मोदी
greater
अच्छा
proportion of salt as compared to the earlier scenario. So, whenever you have evaporation, whenever you have, let's suppose, freezing action, it will always lead to the removal of water molecules. That will always lead to basically an increased proportion of salts left behind, and that will lead to an increase in salinity. Let's
बड़ी किंतु
consider another situation here. Let's suppose. So, all those who are having the doubt that, but the salt is dissolved in water. So, if the water goes, where does the salt come? So, nowhere it is said that the salt is or the water is completely saturated with salt. Water has got much more capacity to take in salt. Some amount of that water evaporates. So, in that remaining solution, the percentage of salt will be more, right? So, all the doubts that you are having is basically when you are thinking about the saturated water condition, where the water consists as much amount of salt as it can contain. But that is not always the case. Water has got scope to add much more salt here,
और
right? So it is not as if If the water evaporates, you will have solid salt particles. That is also found in certain areas. Okay. So let's suppose we consider another situation. Let's suppose we consider a situation of rainfall. Now, when you have an event of rainfall or precipitation, any kind of precipitation, so basically, rainfall or precipitation, they will be able to bring some amount of dust particles along with them. But if you consider rainfall duration over a period of time, in majority, what is added? Water or salt particles? Always water is added in majority, isn't it? So here, as a result of that rainfall, you will have greater concentration of water, greater amount of water presence is something that you will find. As compared to earlier. So overall, in total, here, what do you observe? You will observe that there is more amount of water which is added. So, as compared to earlier, the proportion of salt, they have reduced because of addition of water. So, salinity reduces. Salinity reduces. Now, imagine if we consider the oceanic water, and there you have the river water which is continuously coming in. Now, river water will also bring sediments. But if you consider a larger volume of river water, and if someone asks you that this is dominated by sediments and salts or is it dominated by fresh water? Always it will be dominated by fresh water. So there, this is where you have the addition of fresh water in that case as well. So there, when you talk about it, this is because of addition of water. Addition of water. So that basically means you have the salinity which reduces. Also observed also due to influx of river water. Okay. Now, what happens if, let's suppose, during the summer season, there is the ice which is present and that starts to melt. Now, in those areas, when you have the melting of ice, net addition of water will be observed or net addition of salt would be observed when you have melting of ice. What do you think? Net addition of water? Always. So when you have the net addition of water during melting process, that means again salinity will reduce whenever you have melting. So also this is also due to melting of ice and glaciers. In certain water bodies, you will also find that the groundwater also keeps on emptying itself into the region of, slowly and steadily, it keeps on seeping into the region of the ocean. Groundwater is also fresh water. So that will also reduce the sand in those areas. So basically, all these factors that we have been talking about, all these will be able to influence only the surface. They will never be able to influence the depth or the bottom. Only the surface is where the influence will be restricted to. So surface water salinity depends on various factors. So evaporation. In a region where there is more evaporation, that means there will be more salinity because of removal of water, right? Precipitation. The region where you have more precipitation means less salinity. So that means where you have less precipitation, less amount of rainfall, comparatively, you have more salinity experienced in those areas. Now, when we talk about the region of the tropics, the tropical area. Now, in the tropical area, the subtropics, that is, what is the amount of precipitation, high or low? What do you think? Subtropics. The precipitation is very low, right? Why? Because of the subtropical high pressure belt. Remember yesterday also when we were discussing about world geography and the world climate, we discussed that how in all the various different regions around the subtropics you have the presence of deserts because the precipitation is very, very low. But what about the temperature in those areas? Temperature is high or low? Temperature is very high. So the rate of evaporation will be very high, right? So in the region of the tropics, you will experience that precipitation is very low, evaporation is extraordinarily high. That is why in the tropical waters, the amount of salinity is amongst the highest in the world, right? So that is where the tropical waters are amongst the most saline waters across the entirety of the world. Okay. Then fresh flow of river water. When you have river water emptying itself into the ocean, so that decreases the salinity, more flow leads to less salinity, right? And freezing and thawing means breaking and melting. So freezing will increase the salinity, increases the salinity. Thawing will lead to reduction in salinity, reduces the salinity. Okay. So that is the impact overall. This is the chart which depicts that for easy memorization and easy revision as well. So here you will see that freezing of seawater, then evaporation of seawater, all of these, they will increase the salinity because all of these, they lead to the removal of water molecules from the sample. Whereas precipitation or rain or snow, then basically melting of ice, river runoff, groundwater flow to oceans, all of them will end up reducing the level of salinity. Why? Because they will lead to the net addition of fresh water. All these lead to net addition of fresh water. Addition of water. And this will lead to net removal of water. Okay. So here, this is the kind of a representation pattern between the evaporation and the amount of precipitation. Okay, where you will find that the blue curve that represents evaporation and the red line indicates the amount of precipitation. So at the region of equator, that is at the doldrums, you have daily occurrence of rainfall. Which kind of rainfall is observed at the region of equator? Try to recall that. Which kind of rainfall is observed at equator? Convective rainfall, convectional rainfall. Perfect. So you have the daily occurrence of rainfall in the evening and the afternoon. So here the amount of rainfall is significant. Evaporation also happens, but not as compared to the amount of rainfall. Then in the tropics, you will observe that evaporation is higher, rainfall is particularly low because of the subtropical high pressure. So the rainfall is low. So evaporation is very dominant in this area. So when the evaporation is dominant, means what? And precipitation is very low. That means you will have a higher salinity. So tropics represent the highest salinity. Tropics represent the highest salinity. Then, as you move towards the region of the poles, the temperature not only reduces, just a moment, evaporation completely almost vanishes. So, there also, the salinity in the polar region is very much determined by the melting and the freezing of the glaciers and the ice caps which are present. That
কি
is what
করতেছে ওই ঘরে কে জানে,
dominates
লাইটটা
the
জ্বালা রেখে আসে।
presence of salinity factor. Now, if I ask you another logical question here, that salinity in the tropics is very high and it is driven by less rainfall and very high amount of evaporation. High evaporation is in turn determined by the high temperature in the tropics. Now, here, if I ask you, where is it that the temperature will be higher? In the northern hemisphere tropics or in the southern hemisphere tropics? Where do you think the temperature will be higher? Always north, right? So, can we say that in the northern portion the temperature is higher? So, can we say that in the northern portion you will have significant amount of evaporation, much greater amount of evaporation? So, the salinity at the surface will always be highest around 20 to 30 degrees north in the north of equator, because you have a predominance of land mass, greater temperature rise, greater rate of evaporation is attributed. So, now looking at the factors for the horizontal distribution of salinity. So, here salinity for normal open ocean ranges
যে
between
প্যাকেট না একটা
33
প্যাকেট?
parts per thousand to 35. On an average, it is 35 parts per thousand. It varies between 33 to 37. So, average is 35 parts per thousand. Now, in the landlocked areas such as the Red Sea, it is as high as 41 parts per thousand, while in the estuaries in the region of the Arctic, salinity fluctuates between 0 to 35. And that is because of the influx of fresh water. Why? You also have the rivers in that area, you also have the freezing and melting which is carried out. So, that also ends up determining the salinity. So, this is your oceanic salinity and the representation of oceanic salinity. Observe certain areas now carefully. First of all, start with the vicinity of India. So, if you observe this region of Arabian Sea, and if you observe the region of Bay of Bengal, even South China Sea and so on, you will observe that the region of Bay of Bengal, it has got lower salinity. Why? What do you think is the reason why you have a kind of a greater amount or lesser salinity in the region of Bay of Bengal? Perfect. That is because of influx of river water. There you have large rivers which end up draining into that region. So you have Brahmaputra, Ganga, then you have Iravadi, then you have Mahanadi, Krishna, Godavari, Kaveri. All the large rivers drain into this small water body. Whereas in the Arabian Sea, you have Indus and Narmada amongst the larger rivers. Otherwise, you will find the smaller rivers which drain into Arabian Sea. So that is why, being in the tropics, always the rate of evaporation is low. But here you will find the salinity to be lower over Bay of Bengal. Now, over the region of Mediterranean also, salinity is very high. What do you think is the reason for that? Why salinity is higher in the region of Mediterranean? Good. Because the evaporation, the rate of evaporation is substantially high. Rate of evaporation is very high, landlocked area, so temperature will be higher, so rate of evaporation is very high. Observe that how in the northern tropics in general, the salinity level is significantly higher. Okay? Now here also you will observe salinity is low. Here also you will observe salinity is low. Here also you will observe salinity is low. Here also. Why? All these are the regions for the influx of river water. Okay. Now, in hot and dry regions where evaporation is high, salinity sometimes reaches as much as 70 parts per thousand. Maximum salinity is observed between 20 degree north and 30 degree north latitude. that is the northern tropics. North Sea, being in higher latitude, records higher salinity due to more saline water and warmer water brought by the warm ocean current. This is a warm ocean current. Warm ocean current. So when you have a warm ocean current, that will end up increases the temperature. With the rise in temperature, what is experienced? You have increased evaporation. Evaporation. With increased evaporation, what happens? You have greater amount of salinity which is experienced. Okay, so here, which of the following has more salinity? Always Arabian Sea will have greater amount of salinity as compared to Bay of Bengal. Bay of Bengal has lesser salinity because of influx of river water. Okay, so here, that is influx of river water. Okay. Now this will bring us to another concept. Okay. Let us come to another concept from here. So, okay. So how many of you have a doubt whether this is a live session or a recorded session? This is a kind of a doubt which I don't know why you have this. And this is a kind of a doubt that I have been like solving for I don't know how many days now. How many of you still have the doubt whether it is a live session or a recorded session? Harmeet, does the doubt still prevail? Just merely copy pasting the same question hundreds of times. Again, I would tell you, you are not in a political agitation. You are not sitting in the parliament where you keep on repeating the same thing hundreds of times. So we do take questions in between. You have the subject matter experts who are present there. So I'll tell you that you have asked the question, you have asked the doubt at 7:36 and then 7:36 again, and then 7:37 you are saying that it is recorded or is it live. So better to have that kind of a thing where we don't go forward any kind of doubt that we have. And what is the doubt that you had? What is meant by this? So did you take a look at the previous portion here? Parts per thousand. Did you take a look at this? Right? When I don't reply to the queries immediately, please understand, there are a lot of people who are attending the session. Each and every query, if I keep on taking, then basically that is why we have the subject matter experts. Have patience, have a basic level of decorum in the class. Okay. You cannot expect to be joining the session midway, and you cannot expect to hold the entire session at ransom. That because I am so special, I have joined the session midway. So just do one thing, let other people do what they are doing. Let me clear my doubts first, and then I will again leave the session midway. You cannot have that kind of an approach. Let me be as blunt as I can. Okay? Good. So this is part per thousand. We have explained it. What do we mean by parts per thousand? Parts per thousand means when you express salinity, salinity is always expressed in terms of what is the concentration of salt present in 1 kg of water. So if you have the amount of salt to be around 35 grams in 1 kg of water, so that is where we can say that you have 35 grams in 1000 grams of water. So we can say that salinity will be represented in 35 parts per thousand of water. So this represents parts per thousand. This is parts per thousand. Okay. Is that clear now? Should we move ahead or should we resolve this again? Okay, I hope now the doubt doesn't prevail that whether it is a live session or not. Now, we come over to the aspect here of another concept that we will introduce ourselves with. And this is where we will try to interrelate and interlink it with the portion of climatology as well. So here, when we talk about the two cases, let's suppose you have the factor of seawater, which is present in a region. Now let's assume that the seawater is significantly saline. That means it has got the presence of salt. Significant presence of salt is there in the seawater. Let's suppose here we have the presence of the seawater.
খালি গায়ে নিয়ে যাবা গেঞ্জিটা পরাবো না রোল আউট দিবা না দিয়ে রেডি করে আমাকে ডাকো
Okay.
তোমাকে কথা বলতে
And here in between them, you have the salts.
ওখান থেকে সরবেন তো
So in a way, can we say that the presence of salts, they end up determining the density of seawater? We can have that conclusion that the amount of salt content, the presence of salt, that will end up determining the density of seawater. What is density? Density is how close the particles are packed, right? So salinity ends up determining the density. Impacts the density. Okay, salinity tends to impact the density. Density is also something which gives an attribute to weight. We will come to that. But let us consider another example or another situation. Here, I consider two samples of seawater. Here, let's suppose they are of equal size. Just assume they are of equal size. Let's suppose in the first case, the amount of salt present is for 50 grams. In the second case, the amount of salt present is 20 grams. Now, obviously, salinity is higher here. Is higher. Here, salinity is lower. Now, if I name this sample as A, if I name this sample as B, which will be heavier? A or B? Which will be heavier? Always A. A will be heavier. It represents more amount of salt. So, we can say saline water or water with higher salinity is heavier than water with lower salinity. Any issues up till this point? Any issues, any questions at all? Up till this point we are comfortable? Fair enough. Now, if let's suppose I have a region
of
or an
water
oceanic area where I have
present
the presence of both the saline water, less saline and more saline water. Let's suppose less saline and more saline water. Now, will they readily mix with each other, or will the lighter water float? What do you think will be the condition if you have a mixture? So in that case, generally you will find that water which is lighter, that is less saline water, that will tend to float as compared to the heavier water. Can we say that? Light water will float, it will separate. So less saline water will separate itself. More saline water will deposit at the bottom. We can say that, right? Why? Because, see, you have water which is provided by the river. Now that river water is always going to have lesser amount of salinity, and that lesser amount of salinity, that water, just like in the case of air masses, we had seen that warm and cold air mass, they won't give a moderate air mass. As a result, they will have a separation. Similarly, when you have a water which is less saline, that will always tend to float over the water which is more saline because of difference in weight. So here, what you can have as the case is less saline water, because the density also varies. So salinity impacts the density as well. So
Hello.
less saline water
Dale, dale.
water
Kurva. Gati.
floats
Dale. Dari gati.
on top. We can have this conclusion. So here, let us build up on this concept. So we have seen that you have less saline water in conditions.
Dari gati.
Let me write it down in full.
Hai.
In conditions where the water is consistently supplied
Ah. Ah.
with fresh water,
Ah.
fresh water floats on top as it is lighter. Okay? Fresh water would always float on top as it is lighter. So, in a way, what we see is the arrangement of water in the form of layers of almost. Is this color visible to you guys? I hope the color is visible. Everybody says yes, only one is saying no. So I will assume yes is the fine. And then you have the denser water, more saline water at the bottom. So you have fresh water on top and dense water at the bottom. So what do you observe here? That in the sea, you have in certain situations and in certain cases, you have fresh water on top and denser saline water at the bottom.
Last. Eh?
So can we say that there is an arrangement in the form of layers, and that is what we refer to as stratification. Stratification basically is again derived from the term strata, which means layers. So stratification of oceanic water here refers to arrangement of oceanic water in the various different layers, right? So this is what is referred to as, I will give you the definition as well later on, so don't worry about it. So this is stratification of oceanic water. Okay? So wherever you have large number of rivers coming in, can we say that in those areas stratification can be observed? We can say that, right? Now, as compared to Arabian Sea and Bay of Bengal, where will you observe stratification to be more common? Arabian Sea or Bay of Bengal? Good. Always Bay of Bengal. That is where you have larger amount of fresh water which comes in. Now let us develop the concept. Now, here, let's consider another area where you have saline water through and through. Okay? Now, both of these areas receive solar insolation. That is, significant heating by the sun is received. Now, I will have some assumptions. Let me know if you are comfortable or not. So here, when we talk about this, so here we will have the solar insolation because the water is obviously transparent. So almost transparent, translucent of sorts. So you will have the heat being transmitted all around. Whereas in this case, heat will significantly be concentrated in the top portion because there is a kind of a layering which has been done. So heat will be concentrated in the top portion. Some amount of that heat might percolate in the lower portions, but majorly heat will be concentrated in the some area. So just apply the same logic that we applied in the case of heating of land and water. So out of A and B, where do you think that surface water will get much heat, much hotter, and that too quickly? Where do you think surface water will get hotter and quickly? Always in the case of A, because in B that heat will be distributed, spread across, whereas in A that heat will be concentrated, right? So in this case, heating of the surface water of surface water is more frequent and more intense. Now, when the sea surface water in the tropics, when they get heated much more intensively, which atmospheric phenomena results out of that? When the surface of the tropical seawater gets heated more intensively, which atmospheric phenomena develops? Very good. Tropical cyclone. So tropical cyclones are created when that temperature rises beyond 27 degrees Celsius immediately. There is a development of tropical cyclone. So here, that is the reason why when we talk about the occurrence of cyclones, you have more occurrence of cyclones in the region of Bay of Bengal as compared to the region of Arabian Sea. Is that understood? Is that understood now? If river water floats upon the ocean, then how it erodes the soil? It is the sediments which get deposited and which have a flow. Okay? Is that understood? Good. Right? So basically, that is the reason why you will have greater occurrence of tropical cyclones in the region of Bay of Bengal, in the region of Gulf of Mexico, because there also you have large rivers such as Mississippi, Missouri, etc. You have rivers such as Rio Grande, etc., that end up draining into Gulf of Mexico. In the region of South China Sea also you have large number of rivers draining into that area. So this is the reason why these areas, they are much more frequented by tropical cyclones. That is a concept that you don't find in the books, and that is a concept which is important to understand the occurrence of cyclones. So now you will be able to answer the question why you have more tropical cyclones in the region of Bay of Bengal as compared to Arabian Sea. So now if you are writing the answer that why more tropical cyclones in the region of Bay of Bengal, you can talk about the fact that how Bay of Bengal is narrower as compared to Arabian Sea. So the temperature rises very frequently. You can talk about how the normal Walker cycle, the case of La Nina, the case of normal IOD, the case of negative IOD, all of them can create low pressure areas around Bay of Bengal, induce tropical cyclones. Then stratification of oceanic water also induces tropical cyclone. So that covers your answer from all the perspectives. A question of climatology need not have the answer included only of climatology. A question of oceanography need not, the answer need not be restricted only to oceanography. The better you are able to interrelate the various concepts, that is what will create a difference. Otherwise, everybody studies the same books, everybody extracts the same material. Okay, so here that is what is referred to as the stratification. I'll get you the definition of that as well. Now, here, when we talk about it, so we talk about the vertical distribution of salinity. So, salinity at the bottom is largely consistent, around 35 parts per thousand. Salinity at the surface, it keeps on varying consistently. Why? Because when we talk about salinity at the surface, it will be impacted by evaporation, precipitation, ocean currents, etc. But all these, as we have seen earlier, they are surface phenomena. Melting, freezing of ice and glacier, influx of river water, etc. They won't be impacting the depth of the ocean. These are all major surface phenomena. So salinity at the surface will vary from one latitude to another, but salinity at the bottom will largely be consistent. Now, just like in the case of temperature variation with depth, we also observe that there is a variation on the surface, and in order to attain the consistency at bottom, there is a zone of transition where salinity suddenly changes. That is what we refer to as halocline. Okay, just like earlier we had thermocline, here we have halocline. So salinity changes with depth, but not same on all locations. Salinity at the bottom is largely consistent. So halocline, it is very similar to thermocline, but it measures the change in the salinity zone, distinct zone of salinity change that is experienced. So here, basically, the salinity at the surface is consistent. At the surface is consistent. I will take the doubts for the final 10 minutes. Don't worry, guys. I'll take all your doubts. Most as much as I can. At the surface is consistent, or not surface is consistent at the bottom. Salinity at surface varies. At surface varies. Okay? That is where you will have that zone of transition where the salinity tries to attain that consistency at the bottom, which is around 35 parts per thousand. That is The zone of transition is referred to as the halocline. This is what is the zone of transition. Okay, so here you will observe, for example, here you will observe that how at the region of the equator, salinity is roughly around 35. The salinity is highest where? At the tropics, because the evaporation is high, precipitation is low. So here you will observe that the salinity suddenly reduces as you go to the bottom. In the higher latitude as well, the salinity varies to come to the consistent level at the bottom. So that is where you have the zone of transition, zone of transition, and this zone of transition is halocline. Okay. Now, higher salinity water is much more denser and stays below the water having lower salinity, because salinity is also something which impacts density. So higher the density, it goes to the greater depths. So this leads to ocean stratification, that is arrangement of oceanic water in terms of layers. So that is what is referred to as the ocean stratification. Now, higher salinity in water bodies, when we talk about the most saline waters in the world, you have Lake Van in Turkey, then you have Dead Sea, then you have Great Salt Lake. Now, Lake Van, you will observe that it has got salinity levels of almost 330 parts per thousand. That is, that means in 1 kg of seawater, you have 330 grams of salt. In Dead Sea, in 1 kg, you have 238 grams. In Great Salt Lake, in 1 kg, you have 220 grams. So these are very saline. Most of them you will find, almost all of them you will find, they are present in the subtropical high pressure region, meaning there will be very little amount of rainfall, significant amount of evaporation. So that is where in these subtropical high pressure zones, you have significant amount of salinity, high amount of salinity. Okay. Now, then we come to the aspect of density of seawater. Density of seawater. Okay. The density of seawater. So when we talk about the density, so density is what? How closely the particles, the materials, they are arranged. That is what is density, isn't it? So when we talk about the density of seawater, so that will be impacted by salinity as well. That will be impacted by temperature as well. Both of them will impact the salinity, isn't it? So here, both of them will impact the density. So here, when we talk about the density of seawater controlled by temperature, controlled by salinity. So, if a water is, let's say, very warm or very hot, in that case, what do you think will happen? If the water is very warm or hot, in that case, the what do you think will be the impact on density? Will the density increase or will the density reduce when the water is very hot, very warm or hot? Okay. So I guess many of us are unable to understand the meaning of density in itself. So, okay, fair enough. If I talk about this seawater, I'll talk about two samples. Then then we will understand what is density. Here, if the particles are arranged like this, okay, and here the particles are like this. This is A, this is B. Let me launch a poll. so that I have a get better visibility for you guys as well. So here, which will have higher density out of A and B, which has got higher density? Obviously. So Harmeet, please take a look into what is density first. Okay. Okay. So we have a very small minority for whom density is not clear. So density represents that how closely are the particles packed. That is density. So here density in this case will be higher. A's density will always end up being higher. So, density is contributed by temperature, density is contributed by salinity as well. So, when we talk about now, these are very basic portions of science, guys. I assume you would have studied in your class 7th, 8th standard. Okay, so if not, so kindly go pick up the book for the class 6 to 10th NCRT, the science books that you have, the very basic science book for school. So do take a look at that. You will understand what is mass, what is volume, what is density. You will get a clear concept of that. Okay. So in this case, when we talk about density, so if a water is warm, particles will escape each other. So the density will reduce. If the water is very cold, the particles will come closer, just like in the case of air. So if the water is very cold, particles will come closer to each other. They will pack themselves closer to each other. So then the density will be higher, isn't it? So here, cold water is denser than warm water. Okay, and water with high salinity is denser than water with low salinity. Now let us consider another case here. When we talk about, let's suppose, the tropics. Now in the tropical region, what can we say about the temperature? Temperature is high or temperature is low in that area? What do you think? Temperature is high, significantly high. So as per this, the density should be lower. As per this, density should be low, isn't it? What about salinity? Salinity level in the tropics is high or low? It is the highest. The oceanic water salinity is highest in the region of the tropics. We have just now seen it repeatedly. So this is where it is the highest. So as per this, the density should be high. Should be high. Okay. So as per the factor of temperature, density should be low. As per the factor of salinity, density should be high. What will be the outcome? So whenever you have both the factors at play, it is the temperature which is the dominant factor. Because when you have a saline water which gets heated, there even the saline water will tend to expand. Heating leads to expansion. So if the saline water gets heated, so even that saline water will expand. So whenever both the factors are at play, temperature will be the determining condition. Okay. So whenever both factors are at play, temperature is the determining condition. So even though the salinity is high in the tropics because of greater amount of evaporation, still even that saline water will expand. And whenever it expands, density will reduce. Now, this induces a large scale circulation in the oceans due to the difference in temperature and density. That has got the potential to induce very large scale circulation in the oceans. And I say large scale circulation, I mean from the region of equator to the region of the poles. So, how does that happen? Let us analyze that. Let us understand that. And what is it referred to? So, here we study that under the heading that is thermohaline circulation. These circulations are so very important for the distribution of heat from one region of the ocean to another, for the distribution of nutrients and minerals from one region to another. Many of the marine species, they are dependent on these circulations for the availability of nutrients for them. Okay, let us take a look at this. So before that, let me give you an idea about the average sea level. Let's suppose this is your average sea level. I understand this won't be very significantly visible as of now, but please bear